Yeah, Steve's got those headphones on. You'd think he'd be coming in stereo or something.
Quadraphonic.
There we go. There we go. So let's see.
Is this better? Can you hear me better now?
Yeah, a little bit.
Yeah, a little bit better. Yep.
Okay. I know what to do.
Yeah, but I've really been thinking a lot about the phosphine detection in Venus. That's a big game changer if that turns out to be life creating that.
Well, yeah, I'm sure Libby's going to get into this. Libby, you never had a chance to meet or even know about Carl Sagan while he was still alive, but he was somebody who really believed intently in the existence of extraterrestrial life. And yet he said at one point, extraordinary claims require extraordinary evidence. And I think that applies in this Venus detection.
Yes.
It's like, well, we can't think of anything else that it could be, therefore it must be life. And I just think that's a stretch.
Sherlock Holmes would disagree with you, you realize.
Yeah, I know. When you eliminate all the others, right.
Yeah. I'm amused by that because 4 or 5, I've been, for more than a decade, I have been creating a space exploration challenge for senior aerospace engineers, final projects that they work on as a group for Cal Poly Pomona. And a few years ago, I said, design a mission that would collect samples of the atmosphere of Venus in order to or search for life in the atmosphere, either in situ, during the taking or on the spacecraft, or get them back to Earth in such a manner that they could be tested there.
All right.
So, and they did a pretty decent job. So I just am amused that the science actually may be catching up.
One of the, I encourage everyone who's interested in this particular topic to read the article on National Geographic's website by Nadia Drake, who is the daughter of Frank Drake, by the way.
Oh, wow. Okay.
And one of the things she points out is that even though they used both the James Clerk Maxwell telescope and ALMA for this phosphine detection, it's still a sketchy detection. And it's not entirely clear that it really is phosphine. And so
need a lot of follow-up, that's for sure.
Yeah, and ironically, it didn't take long. The Breakthrough Initiative has already funded Sarah Seeger and a bunch of people to intensify the search for biosignatures in the atmosphere of Venus as a result of this result.
Mm-hmm.
The pace of science can move quickly, apparently.
But if it is real, if it turns out that it's confirmed, boy, then that is big news.
Oh,
Oh, yeah.
Well, the thing is, one of the reports I saw, we'll have to remember that there have been any number of spacecraft that have drifted through the atmosphere of Venus to get to the surface. Pioneer Venus had 3 probes. There have been at least like a half a dozen Veneras. Some of them had mass specs aboard. And I honestly, I saw it in one news report, but I cannot remember that there was ever a detection of organic material in the atmosphere of Venus. And yet that's what the report said.
Well, actually, technically speaking, phosphine isn't organic to begin with. It's pH 3. It's a phosphorus hydrogen compound. So there's no carbon there. But yeah, that it matters in the sense that what if it's
if you believe
it's the same thing,
there.
something's got to be making it.
Well, the thing is, Steve, all right, so phosphine, I'm trying to remember what the atomic number of phosphorus is, but that's the kind of relatively simple compound that would have shown up as a peak in a mass spec. And it never did.
It could be a case of being in the right place at the right time. That's why it wasn't detected.
Yeah, and that's the other thing. The observations that went into this result are whole disk observations. So we don't know where on the disk of Venus this phosphine signature actually exists, or maybe it's just spread out over the whole disk. But like in the case of Mars, where there are these methane signatures, which seem to be relatively localized, it would be very interesting to see if they're localized on Venus and how they would go about getting more spatial resolution to make that determination.
Mm-hmm.
Steve, I think you should resurrect that atmospheric sample return concept.
Yeah. I'll have to dredge it up. It's not too hard to find. Atomic number 15.
So 18. That's
So it's atomic mass 31 AMUs. And there are isotopes. But there's, yeah, phosphorus 30, 31, 32, and 33.
and 32 is the most abundant.
No, it looks like 31 would be.
That would be a AMU of 34, right?
No, 31.
Oh, phosphine. Oh, I see. I got it.
Oh, yes. Yeah. Oh, phosphine, yes. 34. Yes. Sorry, didn't understand. Oh, 35. 31 and 3. Yeah, 31 and 3 is 34. Yes. Sorry.
Okay, so that's let's see. Nitrogen that which is not there would be 30. Oxygen would be 32.
32. But it's not there either. I mean,
Right.
Sulfuric acid is going to be, everything's heavy.
Yeah, that's right.
Everything's heavy.
I mean, that's kind of my point, right? So
Right.
something with an AMU of 34 would be sort of all by itself in that spectrum, in a mass spectrum.
Yeah.
I think somebody is going back through the Pioneer Venus data as we speak to see if there was anything in the descent.
Yeah, this stuff, if it really is there, you'd expect would be bubbling up through the atmosphere.
Well, that's the whole thing. We don't know where in the atmosphere it is. We assume it's in the upper atmosphere in the cloud deck or higher because that's where the emissivity would be greatest, but it's not necessarily in the cloud deck.
Kelly, this is Chuck Allen.
How you doing, Chuck?
Pretty good. How have you been?
Great.
Hasn't phosphine been detected in Jupiter's atmosphere as well?
Yes, but in Jupiter and Saturn, the physics are that it's created at great depth under very high temperature
High
and pressure,
temperature conditions, yeah.
and then gets convected into the upper atmosphere.
So we got a number of people watching right now. Jeff Wise is with us here. Nicholas Rochia. Hello, guys. I'm on the roof making photos. Bernard 72. Okay, that's cool. Dusty Haskins is with us. Brett Blake. He says, I still think phosphine sounds like a brand of toothpaste.
or kitchen cleanser.
Yeah, that's right. Now with phosphine. Yeah. Venus, now with phosphine. Astro Beard is, of course, with us, but he's in our VIP group here. A guy named Killshot. I have a question. All right. Libby and the Stars. Good evening. Thanks for posting in there, Libby. Dusty Haskins says he's been basically looking forward to this all week. That's great. Aaron Thompson, I just thought I saw a comment by NASA saying that they're going to prioritize a probe due to the Venus data. I wonder how that's going. Brian Fanning, hello, listening from New Jersey. Love these parties. Question, I always thought that the moon phases were due to the Earth's shadow casting a shadow on the moon. No, it has to do with its orbit. There's good.
It's self-shadowing.
Yeah.
I'll tell you, I taught high school astronomy for 6 years,
Yeah.
and teaching the moon's phases was conceptually one of the toughest things to get across. As simple as it might seem, it's really the notion, that the moon goes around the Earth and how the sun shines on it changes as it goes around the Earth. It never sank in.
You couldn't get the room dark enough to demonstrate it, right?
Yeah. Hey, Chuck, your microphone sounds a little bit muffled. I don't know why.
Yeah, I know. I've got new equipment on the way.
That's cool.
Is the volume low?
No, good.
Just put on your mask and we'll think it's that.
Yeah.
That's right.
I had a catastrophic laptop failure, so I had to transfer my flag to the desktop, and I'm using earbuds. So I have a new cam with mic and speakers coming. It should fix it.
Brett Blake says, what is phosphine? A potassium atom surrounded by some hydrogen? I can't believe that just doesn't occur.
Yeah, well, that's the $1 million question right now. The authors of the paper looked at, I don't know, something like several dozen possible reactions, and there's just no way to create it at the levels that they see it, which is, parts per million, but that's a lot.
Yeah.
And just to make sure it's phosphorus, not potassium.
Europa is one of the largest moons of Jupiter, and we believe that Europa has a subsurface ocean tens to hundreds of kilometers thick. And so this ocean may be one of the best places to search for life in the solar system.
There's been 3 space missions that have provided evidence for Europa harboring liquid water. The first one is Voyager in the late 70s. The second one is the Galileo mission in the late 90s. And most recently Hubble, which detected plume-like emission from hydrogen and oxygen, which is closely related to the existence of water beneath its surface.
Well, hello everybody. This This is Scott Roberts with Explore Scientific, and we are here with the Global Star Party 9. And with me is, of course, Chuck Allen, Libby and the Stars, Jerry Hubble's here, Astrobeard, David Levy, Gary Palmer, John Crisp, Kelly Beatty, Steve Edberg, Cesar Brolo, Steve Malia, Rodrigo Saleda, and Space 65 out there. So not sure who this guy is. All right, but anyhow, and we've got a couple other guys online too. But we're happy to have you here. Glad that you're joining us again for another Tuesday night Star Party. We have great talks, and we have. We're going to have some space artists join us, which is really cool. They'll be joining us later. We're going to see people come in and out of this event probably throughout the night. Chuck Allen is joining us from the Astronomical League. He'll be asking questions for door prizes. And we have, again, a global star party, Northern and Southern Hemisphere. Also from Europe with Gary Palmer. Somebody else that says UK Live, I think that is still Gary Palmer because he's actually taking images live right now. And Tyler from Customer Service, who's blacked out with his screen. So
yeah, I'm working with Tyler, Scott.
Are you
we're both on the MSRO now? He's got it set up, and we just started. We slewed to Vega and took a picture to make sure we're getting some stars. So
cool. So we're gonna have some live views tonight. That's very cool. Ron Delvo's joining us as well here. So, but as tradition holds, we're going to have David Levy join, or he's already joined us, but he's going to give the opening talk and remarks and probably some poetry. I have to say that I look forward to this star party every time, and I think that it brings me a sense of warmth and happiness, really, just to know that so many of my friends that I've known for such a long time are on with me live tonight. Some new people also that I've gotten to know better. And so we'll get started with David. I know that all of you have enjoyed his talks with each star party, and he's a real treasure, and it's great to have him. So David, I'm going to give you the stage.
Thank you so much, Scotty, and welcome to our 9th Global Star Party. And I have to tell you at the very beginning that the half hour that we spent together just as the group of presenters, just getting to know each other and talking about recent news and astronomy and stuff, is one of the half hours that I prize more than anything else during this time, because it really gives me an idea to find out what's really happening. We are all now going through a dreadful period in our history. This is obviously, as I'm sure you've heard, the most serious pandemic since the flu in 1918. So it was over 100 years ago, and this is showing absolutely no signs of going away. Life is rough. Schools can't happen normally. Universities, nobody can work. Flights are almost empty, those that are flying. And it's really sad, except that the night sky is still here. You could say, if you want to be negative, that the night sky doesn't care, doesn't give a darn about what we're doing and about what little problems are happening here on this tiny little pale blue dot, as Carl Sagan said. But on the other hand, maybe it does. Maybe in its lack of caring, the night sky beckons us. It beckons us. Forget about, for just a while, just 15 minutes, half an hour, forget about what's happening on the earth, for happening in the world. Go outside and look at the sky. See what's there. Look at Jupiter and Saturn so close together, high in the south right now. Come out again in a couple of hours and you'll see Mars better than it's been in a decade or more. Just absolutely magnificent. Come out and take a look through a telescope at some of these planets. Watch Venus come up in the early morning sky. So beautiful and bright. And as Libby, I think, is going to tell us, and others, we are having some extraordinary news coming from Venus right now to talk about. The sky is something that's different. It's permanent. It offers a sense of peace and a sense of loveliness. And I'm hoping that if we do nothing else in this star party, we will be able to accomplish that, to persuade the viewers here around the world in North America, South America, Europe, and other places around the world to enjoy the night sky and just come out and enjoy it. You don't have to know anything to be an amateur astronomer. In fact, the word amateur itself comes from the Latin to love. If you're an amateur astronomer, you love the night sky. I'm closing tonight with two quotations. Both of them are adaptations of poems that other people have written. The first one was originally written by Sevilla Martin in 1905. It was a religious poem she wrote, His Eye is on the Sparrow. And I changed it around to be something about the night sky. Whenever I am tempted, whenever clouds arise, when songs give place to sighing, when hope within me dies, I draw closer to the sky. From care, it sets me free. My eye is on the sky, and I know it watches me. My eye is on the sky, and I know it watches me. The other one that I have tonight, I wrote in a period of a couple of hours when I was having some insomnia a few days ago, and it is called a variation on a theme, actually Cosmic Variations on a Theme by Leonard Cohen, with a David Levy twist to it.
Good.
It's time to go outdoors tonight. The sky is dark, some stars are bright. The Milky Way shines overhead, now see ya. A comet rises in the east, with end to strife. It brings us peace and calls us to a cosmic hallelujah. 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 Back to you, Scotty. Thanks.
Wow. That's awesome. That is awesome, David. I want to tell you, I'm looking at, of course, at comments coming in here, and Jeff Wise had mentioned, if I can pull it up there, he said, I did not realize just how much I enjoy Mr. Levy's presentations. He is an amazing person. And I think that we all feel very special that you're here, David. So thank you.
Well, thank you. And especially thank you for that comment, because it does mean a lot to me, especially now.
Oh, yeah. Yes. Well, up next is a person that has a voice that's warm and familiar to most amateur astronomers. I've often called him the voice of Sky and Telescope magazine, but to me, he's also the voice of astronomy. He is the voice, he's the familiar voice that echoes the love I have for the universe. And, when you meet, and I'm speaking of Mr. Kelly Beatty, and when you meet him in person, you'll know how smart and amazing and charming the guy is, but how lucky it is that we have him in this world. And tonight he's giving part 4 of his 7-part series of the State of Amateur Astronomy, past, present, and future. And so I give the spotlight to Kelly Beatty.
Oh, thank you so much, Scott. Wow, it brings a tear to my eye. say such nice things about me every week, and I keep trying to live up to them.
It's all true, though. It's all true.
So for those
it is.
who might not have been with us the past, we've sort of followed the arc of the development of amateur astronomy as the passionate pastime that we all share here, from the post-World War II years through the heyday of the space race and to the beginnings of the pall of light pollution that envelop almost all of us. We're going to take a walk tonight through a sort of resurgence that has taken place, I would say, within the last 20 years or so, having to do with the availability of amazing equipment for amateur astronomers. Now, it remains to be said that those of us, there was a huge spike in popularity in amateur astronomy during the space race, during the late 50s and early 60s. And a lot of people got involved. They were swept up by, the whole notion of astronauts and exploration and so forth. Those people are all like 50 years older now, me included, and David included, and a couple of the faces that you're going to see here that I recognize. And with that time, in addition to gaining wisdom, I guess, over time, comes a sort of increasing reluctance to get your tail outside at 2 or 3 in the morning to watch an occultation or a meteor shower. And one of the things that has happened to rekindle interest is the availability of telescopes and equipment that hadn't been imagined during the space race. I was looking through old issues of Sky and Telescope, and in the 60s and 70s, there were all kinds of telescopes available from garage operations and refractors, and everyone, those of a certain age, remember the Unitron refractors with the turret on the end with 6 eyepieces that you could dial in, and boy, wasn't that fancy.
Yeah.
But those telescopes were all rather modest, ultimately, in terms of their aperture. I mean, the refractors were what we call achromats, which had simple 2-element lenses that had issues with color fringing and so forth. And today, we are the beneficiaries of a cornucopia of like exquisite astronomical gear, some of which you'll have shown to you later this evening. A lot of which Explore Scientific sells, other manufacturers sell, and I think the pivot point in all of that came during the mid 1980s with the arrival of Halley's Comet. And this is sort of where I put a stake down. Some of you remember a chain of stores called the Nature Company, which evolved into Discovery Channel stores. And I used to go down at Christmas time and watch people buying telescopes for their kids, 8 and 10-year-olds who were precocious and interested in astronomy. And that was the beginning of what I would call the $100 telescope. It was the first wave of optics, which until that point had either been developed here in the United States or in Japan or maybe a little in Taiwan. And generally they were good quality telescopes. We got this first wave of telescopes from China that were incredibly inexpensive, under $100. And so I would watch these parents buy a $100 telescope and take it home. They knew nothing about telescopes. They only knew that their kid liked telescopes, and they would take it home. They didn't know anything about telescopes. The kid was too young to really know how to make it work. And so I think in some ways, the manufacturers of that era did themselves a disservice by rolling out these really inexpensive telescopes, department store scopes we came to call them, because it discouraged a lot of people from moving up in the food chain to better quality, because they loved what they were seeing to their small scopes and they wanted something bigger. I want to show you an example that remains today. This is a telescope that I bought at a CVS, right? It's an 60 millimeter refractor, and I want you to notice the price. $14.99,
Jeez.
Jeez.
right? I bought it at a CVS at a drugstore.
Yeah.
Imagine what the quality of that telescope is, and that's sort of one of the holdovers that we have. And yet, what I might call the second wave of telescopes from China brought a new sort of maturity of the art, and companies like Cinta and JOC, which is the company that Explore Scientific partnered with, in the right hands with the right design, suddenly the Western market was flooded with really good quality telescopes that were incredibly affordable compared to old standards. And some of you are old enough to remember that a Dynoscope RV6, a 6-inch reflector with a clock drive, sold for $200, which in modern dollars would be something like $1,700. I mean, no one would pay $1,700 today for a 6-inch reflector, and that's sort of emblematic of how far we have come with our technology, with the availability of really good quality optics. I have one other I'm going to show you right here. Many of us have traveling telescopes. This is mine. This is an entire 80 millimeter f6 telescope with a go-to mount in a carry-on bag that I can take with me all over the world.
Cool.
And it's had a few modifications that I've made along the line. But the thing is, not only have the optics become better, but the whole technological revolution, the go-to telescope revolution, has made it more amazing and easy than ever for someone who knows nothing about the sky to have a telescope that can literally find its own way in the sky. There's more than one telescope manufacturer now that has a telescope that literally you set it up, you plug it in, you turn it on, and it finds exactly where it is in the sky by mapping the stars that it sees against a database that it carries, and it automatically knows where it is. And this go-to revolution, if you want to call it that, harks back to the late 1990s with the introduction by Meade, and Scott probably remembers this. And Scott, by the way, I think you should chip into this conversation whenever you see fit, because you were certainly on the front lines of all of this.
Sure.
The Meade ETX 90 EC, it was a 90 millimeter Maxitov telescope.
Right.
Way more focal length than any beginner ought to have, all right? But that's beside the point. But it had go-to technology. Literally, if you took it outside and you pointed it at two stars in the sky and told the telescope, all right, this is Aldebaran and this is Vega, it would know where it was and would be able to guide you to, in this case, 12,000 different objects. And this is a comment by Leif Robinson, who was the editor of Sky and Telescope at that time when we reviewed the ETX.
I remember.
He said, here's a prediction. The ETX AutoStar concept will go down as the greatest happening in amateur astronomy yet. Indeed, I believe it will grow the hobby on a scale heretofore unimagined.
Wow.
Really profound words, and we all kind of scoffed at Leaf, but the reality is that these go-to telescopes have indeed revolutionized how we go about stargazing, and especially in light-polluted settings. A go-to telescope can show you things that you would not have a prayer of finding if you use traditional star hopping methods.
That's true.
And so it took all of us 50 and 60 and even 70 somethings who had kind of felt we were past our prime in terms of observing, and suddenly given us a new lease on life. I took a count. I have 12 telescopes in my garage.
Wow.
All right. Now, most of them are small telescopes. That's my thing. Small telescopes. I love to do observing with kids, which I know some of you do. I know, David, you like doing that as well. But I have, surely I don't need 12 telescopes, but I keep coming across these really neat telescopes that I say, oh, that is such a cool idea. I need that.
Yes.
And so that's what I think that's what the importation of Chinese and Taiwanese and still Japanese telescopes has given us. There really aren't that many US based manufacturers of scopes anymore. Teleview and Astrophysics come to mind, but really for the mass market, these amazing optics coming out of Asia have made it so easy for us to find really good quality telescopes, either in highly corrected refractors that show us crisp pinpoint images of the stars, to gigantic Newtonians on simple mounts that can be pointed. Things that were never available to us before are now. And it's kind of reawakened in me, and I suspect a lot of you as well, the urge to go outside and see that starlight like we used to do when we were young.
Oh, yes. Yeah. And in ways that many people never imagined. When I first got involved with the go-to telescopes, I recall some of the old guard telling us that we were destroying the hobby of astronomy, that to allow people to robotically go from object to object ruined our ability to understand the sky. I will admit that there were people that never quite learned the sky, like Reverend Evans, for example, who could almost robotically move his arm and find hundreds of galaxies to search for supernova and galaxies, that kind of thing. People like David, who still sweeps the sky, nightly for comets with his Dobsonian, and probably every tiny little asterism in the sky is very familiar to him. But it did allow amateur astronomers to enter into pro-am projects that maybe they never could have quite completed before, to do surveys of galaxies, and for people to do astrophotography now often from the comfort of their own living room. Okay. And no matter,
as we'll see demonstrated here later this evening.
Yeah, that's right. And so we are, I will take a moment here in a couple of minutes to see a live image coming from the UK with Gary Palmer's telescope of the Pleiades before we move on to Libby. But, I think, Kelly, I think that you touched on some very important aspects of our hobby and have kind of brought us up to date, nearly up to date to where we are now. Go-to telescopes are now commonplace, but I sense that amateur astronomers are taking the next big leap in this golden age of astronomy. So,
yeah, and next week we're going to be discussing the advent of digital imaging and how that has completely transformed how we see the night sky.
That's right. That's great. Okay. All right. So I'm going to go back to our gallery view here. Gary, you have, I assume that you still have some clear skies out that way. Is that right?
Yeah, we have. I've changed the target tonight just because Pleiades was starting to jump out a little bit. We've got some high cloud here, so I'm just going to bring this up and I will share the screen with you.
From the UK looks like of the Pleiades.
I've moved over to M45 at the moment.
5 then, okay.
Sorry, M42. Losing it. It's 3:30 in the morning here, so
yes.
Switch over to there.
Let's just take a couple of minutes and then we can go on.
Hopefully, that should be sharing with you now.
Oh, M42.
Yep.
Absolutely.
It is really, really low at the moment, so it's literally just coming into view.
Mm-hmm. Now, these describe what the equipment's like a little bit, and
there's a 115 mil refractor on there. No filters on it. We're running some tests on the camera tonight, so we've got the new ZWO ASI 2400, which is their new full frame camera.
Oh yeah, with the giant.
And this is in ROI, so we brought this all the way down, right the way down to ROI. So if I very quickly get some control back, there we go. Stop the capture on there, and then we just run this over. If I run this into full screen and just bring in a quicker time, somewhere around there, you can see how far zoomed in we were then. We were really zooming right in on the sensor and using the abilities of the camera. So even though the object might look distant, yeah, we can now change this, and we can bring this all the way in, kind of right the way in. And when you're saving these save as they are. Yeah, so one of the beauties of these cameras now is we can play around with this. We're not fixed on our size of the image coming in. We can play around. So that's starting to come in now.
Okay, beautiful, beautiful. It's awesome. We'll come back to this if you still have some clear skies. And at this time, we're going to go to Libby and the Stars. For those of you that might be new watching this program, Libby is 10 years old. She is intensely interested in astronomy and space exploration. She decided a while ago that she was going to talk about Venus tonight. And this was before the recent announcement of the discovery of phosphine in the atmosphere of Venus, which has really sparked a lot of intrigue about the possible signature of life within the atmosphere, maybe microbial life in the atmosphere of Venus. So lots of conjecture, still not any confirmation, but it is tantalizing. And so Libby, I'm going to give you the spotlight here. How do you feel about being with all of these great astronomers tonight?
It's pretty amazing.
Yes. Yeah. Well, it's amazing to have you here tonight too. So, what can you tell us about Venus? Do you have some?
Well, back a long time ago, before I started my very first call, about 2 nights before, I made a whole list of 56 topics about space I want to talk about while doing the calls. And Venus was one of them, because I was doing the planets in order in our solar system. And news came in just in time. Like, I was happy because I was like, I can't find enough on Venus, and I was writing down, and I couldn't find enough. And then my mom was like, hey, look at this article. And I'm like, whoa, there's life. So apparently there's a chemical in the atmosphere that could be able for little tiny microscopic life to live in the atmosphere of Venus. And one of Jupiter's moons may have oceans. And if there's oceans on Earth, if there's oceans and there's something in the water for a long time, it can start to grow moss. And I wouldn't say moss is completely living, but maybe it could live under the water. But I was definitely excited about that news. And I was like, I wonder about, like, could the moss live in the water, the microscopic bugs, and if there's any way NASA could launch anything into space. And I researched more about why NASA wouldn't let anybody go to Venus. And it was because it is scorching hot. Yeah. There's lava, volcanoes. It's hot enough to melt lead. And the circuits overheat in less than a day. So they would have to gather as much information in a little bit. But they do send orbiters, and they let them travel around, and hopefully they can get enough information from looking at the surface without putting someone on there and getting melted. That would not be pretty.
That'd be good.
Yeah. No. just the whole thing just starts melts.
Yes, that's right.
Maybe we'll send someone to orbit around Venus or the moon to be able to have a huge telescope and look down at Venus. Because also with a telescope, you're not only in the night sky, but if you see a bird in a tree, you can also look at that.
Mhm.
So they take a huge telescope up there and they try and look through it instead of going on the surface. That would work, but you would only see the clouds. And the clouds cover the surface of Venus, and it creates a greenhouse effect. So it is extremely hot, and the atmosphere is so thick you can't see far, and it just creates a greenhouse effect. So on Mercury, when I did my Mercury presentation, I said it's cold at night because there's no atmosphere to retain the heat. So all the heat just stays on Venus, and it just creates so much hotness. And there's little slates of rocks. NASA believes there's little slates of rocks and volcanoes, and just under that it's just like lava and stuff. And I was like amazed. I was like, back then in the 80s, I used to have NASA TV going on in my background when I was doing school, and I had to turn it off because we got a lot of TV bills, but I was listening to it and they kept on playing the same skit over and over again from the 80s. And it was basically like an introduction of the solar system for NASA.
Right. Right.
And it was like, we believe Mars has all life. And I was like, oh, yeah, me too.
Mhm.
And then I'm like, what? It's on Venus. It's in the completely opposite direction. It's on the hottest planet where humans can't even live. But it turns out it's in the atmosphere.
So Libby, do you think a lot of kids think that that we will find life on other planets, maybe moons, or do you think we're going to find life out there?
Yeah. NASA released the golden record, and I don't think that was the right way to approach it, because I don't think some tiny little microscopic bugs are just going to turn on the radio and listen to Earth. I think they're probably not going to listen to Earth and understand us in any language, but they probably will.
Mm-hmm.
They probably will find life out there, not with the golden record they sent out, inspecting little tiny microscopic bugs turn on the radio and listen. But they will find life out there, maybe with a microscope that definitely send an orbiter around and see if you could send a telescope up there. But Venus is scorching hot and it covers the surface, so maybe if you went a little bit more down into the atmosphere, you would be able to look through the atmosphere and see stuff, because that's where we're expecting life to be. But
Right.
other than that, you'll just melt apart.
Yeah. Mm-hmm.
That won't be fun.
So Libby, do you hope that in your adult life, you get into university, that you can do some research on a planet like Venus? Would it be Venus that you would want to check out?
I've always wanted to see Mars a lot.
Mm-hmm.
Especially NASA's working on it now. So by the time I'm adult, they'll be like, hey, we have a hotel on Mars. Want to come and visit?
Right. You might be right about that.
Yeah, they're doing that with the International Space Station, I think. So like $1 million visits to the space, but hopefully Mars. But after that, I really want to visit Neptune. One of my friends that was in my cabin at space camp in love with Neptune. She's like, I want to go, but I'm not good enough to be an astronaut. So I was like, I'll go and take pictures for you.
That's very kind.
It'll be cool there.
It will be cool. Well, Libby, thank you. Is there anything else you want to say in closing? Any words of advice for young people interested in space at this time?
School is good. Stay in school.
Stay in school. Okay. All right. Well, that's great. Well, Libby, thank you. Thank you. Well, I'm going to take the spotlight off on you. We're going back to gallery view, and we have with us Kelsey Poor from novaspace.com, which is Kelsey is Kim Poor, the space artist daughter. I imagine that you might have grown up in the gallery and have lived, eaten, and breathed space art for a very, very long time. I think that you're also involved in operating and it's great to have you on today.
Thank you for having me.
Yeah. So what can you tell us about NovaSpace?
Okay, so NovaSpace started, can you all hear me okay?
Can hear you fine.
All right, NovaSpace started in 1978. My father, Kim Poor, was a space artist. And we started taking other people and putting them in the gallery, and it just snowballed into this huge space art gallery. We're still the only people who solely sell space art.
Mm-hmm.
So let me show you my screen.
Okay.
I have my, okay, so this is my company. This is Michelle Roush. She is our artist of the month this month. And I really wanted to bring her on with me because we're featuring her. This is the first time we've made prints for her. And these are all limited edition, signed and numbered. And they're beautiful, and you can get them framed if you want. We have a framer who's been working for us for 20 years, and she's really good at picking them out. So I just wanted, I want to share my love of art, space art, with you guys. And I'm sure you'll see more of me every week. I have lots to talk about.
That's cool. That's very cool. Okay, so do we want to bring Michelle on and let her share some
Yes.
work? Okay. All right, so we'll do that. And here we go. And let me find you, Michelle. Here you are. So Michelle, I was on your Facebook page today and looking at some of your work on NovaSpace, and I understand that you're an engineer and an artist. So I think that's a little unusual combination, so that's very, very cool. That's very cool. So how long have you always drawn? Have you always been interested?
Thank you, Scott. Do you hear me okay?
I hear you fine. Can you hear me okay?
Yes, yeah. I can.
Okay.
Thank you. So I've drawn all my life, and I consider artists are engineers and engineers are artists because we're always drawing the unknown or designing the unknown. So there's a lot of engineers. I find out that they have a very good creative side, and when they are like chief engineers, they are very creative. So we're finding more and more engineers that are very artistic.
Right. And so what is it that you like to specialize in? I think I've seen a lot of your work with astronauts, the space explorers, spacecraft.
So I've been an engineer working for the aerospace industry for many decades, and I recently became a AIAA associate fellow. So AIAA is American Institute of Aeronautics and Astronautics, and what I try to do is I try to revolutionize the technical world with a contemporary touch of art. So I've done photorealism style of artwork but I want to capture the emotions of people, just like Libby with her wanting to go to Mars, or even the feeling of what's happening in Venus. So I want to share, I don't know if Libby can see this. This is my rendition of a hotel on Mars. So it's a little bit whimsical. We have Robert Bigelow and Marilyn Monroe. So it's so wrong, it's right. And they're on Mars, and this is called Viva Las Mars.
Great. I love it. I love it. So you are the artist at Nova Space this month. And how many works do you have on exhibit there at this time?
So right next to me is a print that is being reproduced at Nova Space, and they're only making 20 of 20. And they're going, and I really like this moonscape. So my moon right next to me is not gray, it's pink. And it does help when you come at the end of the day that you have a little drink and you just select the certain colors you like. You pull them, and you're like, I feel this color, and you make a certain surface of the moon. So this one has been already debuted at an organization in Las Vegas. And Al Warden, he was inducted as the distinguished winner in 2019, excuse me, and in honor of his lifetime achievements. So this one is called Moonscape. So that's one that I can share with you right here. And another one, we are enjoying the 90th anniversary of Pluto. Yes, we consider it in Arizona, most of us, a planet. So when I was in Las Vegas during the time when Al Warden was being inducted, I created my version of Pluto, and the inspiration came because of all the Marilyn Monroe movies I watch and how she smooches the top of a forehead of a bald guy. And I thought, this Pluto needs a smooch, and the whole celebration is called I Heart Pluto. So this is also for sale. This is a very simple print that I have, but Nova Space offers a beautiful 12-inch by 12-inch handsomely framed piece. So
I
have the others.
Are these prints all signed? Do you sign them?
Yes, I do.
Oh, wow. Okay. Excellent. Excellent.
And I do have another type of artwork that I changed a little bit because of inspiration came when Al Warden had passed away. And as you know, art is a very good therapy. Even if you don't know how to draw, and you're like, I don't know how to draw, but I'm upset, put something in your hand and start doodling. You will be very surprised what your body wants to create. And there was no tiki astronaut design, so I designed my own. So this is my astronaut tiki.
I might buy one. Yeah, I like tiki.
And then I went to a textile medium and I put it on a Hawaiian shirt.
Awesome. Well, that's great. Michelle, it seems like that you really celebrate all aspects of space exploration, not only from the work that you do, but the way you express yourself, the vision that you have, and the way that you want to share that vision. So that's great, and I love it. And I really appreciate you being on our program tonight. Anything else that you'd like to share before?
Certainly. So, of course, you can't go out without a matching mask. If you only go out so few times, you got to go out in style. And the last thing, before least, I have a postcard, and I'll put my email address. I can send you a postcard of Al Worden, which is the spacewalk. Yeah, the technical term would be EVA of astronaut Al Worden, but I kind of like the spacewalk. And he has the infamous world record of being between the Earth and the Moon and holding that record still. So, Libby, I know you said you're not sure if you would be an astronaut. Hopefully she's still on there. I would encourage you to become an aerospace engineer. We need more engineers. I'm an engineer. It's a lot of fun. Yeah, it kind of is hard, but hard is good. And we have an organization, AIAA, which people of all types of disciplines can join. I am not an aerospace engineer, but I am an electrical engineer, my first degree, and an information systems engineer, my master's. So we need them all to do what we need to do to get into space and find those worlds.
Awesome. Well, thank you so much. How about you, Kelsey? Or do you have any parting words for us while we're before we go to a break?
Yes. You guys come visit our webpage. Come take a look, novaspace.com. I'd like some feedback from you guys. I'll see you next week. We'll talk more about space art. And I organized an event called Space Fest with my family. If you would let me talk about that with you.
Absolutely. Absolutely. That's great. That's great. Well, thank you both for taking your afternoon or evening to share your love for space and space art and to let us know more about novaspace.com. That's very cool. Very cool. And I look forward to seeing you next week.
Thank you.
Take care. Take care. Okay. So, well, next up here, before we go to break, we're going to take about a 10-minute break. But before we do, we are going to talk with Chuck Allen. He is the Vice President of the Astronomical League. Chuck, are you still online with us?
I still am. Can you hear me?
Right. So the Astronomical League is the official sponsor of our door prizes. And this is the way this works. They will ask a question. You research the answer or find the answer to that question. If you just happen to know it, that's great. You will email your answer to Kent at, I'm going to put it right here in chat for you guys, explorescientific.com. Don't put your answer in the chat box here. You want to put it in email, okay? And the first one to answer that question correctly will become the winner. That is verified by the executive members of the Astronomical League. They will then announce to you that you are the winner and notify us to send out your door prize to you. So the first door prize up will be an Explore Scientific eyepiece of your choosing. So this is exciting for anyone that loves visual astronomy. So what's our question, Chuck?
First question. Are we doing the questions or answers to the previous ones?
Well, let's do the answer to the previous one first.
I'll do whichever you like.
Yeah, let's do that one and then ask the question.
All right. I need to share a screen at this point.
Yep.
All right. Let's see. First of all, if I look a little tired, I just finished my 58th all-nighter at my remote site in the last 25 months, and so my sleep cycles don't exist. My circadian rhythms are something akin to a very poor junior high school band's. Okay, so here we go. The questions that were asked last time, first of all, can you hear me okay?
Yeah.
I'm jury rigged here.
You're a little bit muted on my end.
Can you hear me at all?
I can hear you, but it's very muffled.
Yeah, it's just that's just his sound system.
Okay.
Yeah, I had to transfer. My laptop failed the other day, so I'm in between systems here.
It's all right, Chuck.
All right, first of all, let's go to full screen here. Hang on. Okay. That's not it. Hang on. All right. Sorry. Why is it doing this? I'm sorry. Hang on just
There you go.
Yeah, hold on just 1 second. I do not understand what's going on here. I'm going from current slide and it's showing a different slide altogether. Hold on 1 second.
See the, if you just click on that one slide, you don't have to go into presentation mode, right?
Okay.
That's fine.
All right. Anyway, what important discovery was made by the Hale 200-inch telescope team on September 6, 1997? The answer to that, of course, was the discovery of two new moons of Uranus, Caliban and Sycorax. And the winner that we determined, and I don't necessarily know these names, it was C. Lewis at knology.net.
Oh yeah, Chuck Lewis. Okay.
Chuck Lewis. Okay.
Okay.
Here's one of the discovery images of Sycorax. The previous image showed Caliban. Caliban, by the way, is about 37 miles in diameter. Sycorax about 74. And these are, I think, the two faintest moons ever detected from ground-based telescopes as well. The next question that we had was, what Astronomical League observing program is named after a famous French astronomer? That, of course, Charles Messier, the Messier observing program, which was the first League observing program more than 50 years ago. We have 74 of them now. He did his observing from a little porch at the Musée de Cluny in Paris that's visible here, which I had a chance to visit on a trip there one time. I felt like it was a return to Mecca. It was so incredible to be on that roof. I had to talk my way up there because it was under construction at the time. The third question, the winner of that was John Johnson. He was the first to answer Charles Messier. So John Johnson won that one. Question number 3, when does the next observable total solar eclipse occur in the U.S. and at what time universal time is maximum eclipse? That answer is, of course, April 8th, 2024 at 1817 universal time. And I believe the eclipse will be visible over Mexico before arriving in the continental United States. And the winner there is Dave, and I have a last name of NG. I'm not sure if that's
It's David Ng.
Okay, he is the winner of that one.
Yeah, good job, Dave. That's great. Yeah, he's been working. Normally he's on these programs, but he's been very busy recently.
Yeah.
So. Excellent. Well,
you want to go on to the questions, or
let's go on to the questions, and we'll do just question number 1, and then have you ask questions as we go along the program.
Okay.
Okay.
Question number 1 for tonight. I have a milk dipper, have an alpha star that is only my 16th brightest, and in Greek mythology am poised to avenge the slaying of Orion. What constellation am I?
Ah. Excellent. All right, so you're going to want to take your answers and email them as quickly as you can to kent@explorescientific.com. And thanks, Chuck. We'll come back to you on the next break. So,
thank you.
All right. So at this point, we are, if you want to stop sharing your screen there, and I'll take us back to speaker view or gallery view. It's like Hollywood squares, astronomical squares. There we go. There we go. So at this point, guys, we're going to take a 10-minute break. hope you're enjoying Global Star Party 9 so far. We do have some live views, or it did have some live views coming through telescopes. And hopefully we have some more after this short break. So I will go to that next. And let's make sure I'm doing this correctly. Here we go. And we'll be back.
Hey, Tyler, can you hear me?
Hey, Jerry, I can hear you.
Who's that?
It's Steve.
Oh, Steve, how you doing?
Doing well. How are you?
Good. So I've got Tyler on the observatory with me on Type VNC, and we've been taking pictures of the dumbbell. I've been showing him some things on the observatory. I thought, so I just got off on the phone from him, and I thought he was going to turn his microphone on. I don't know what, I don't guess I can share my desktop because it'll overwrite what Scott's got showing up there. Maybe, I don't know.
Probably.
Yeah, it probably will, Jerry. Yeah.
Yeah, I don't want to do that. I'm just so we've got smoky, transparent sky. I mean, not so transparent skies, but we can see a ton of stars, and the seeing is excellent. I've got typically when I image bin 2, my stars are like 2.5 pixels. But it's down, it was down earlier to 1.7 pixels, full width to half maximum. So the seeing is excellent.
Nobody likes a bragger, Jerry.
Now right now it's 2.1 pixels, which is still a little bit undersampled.
I haven't seen a star in over a week.
Oh really? Oh man, you should see this. I'm on M27 right now.
Can we mute Jerry? He's making me sad.
Just shut him down.
Yeah.
I'm looking at all these little posters here from the prior star parties and stuff like that, and just really amazed at how many great astronomers and people have visited and talked on these star parties. So it's been really cool. Real privilege for me, that's for sure.
Oh yeah,
hang
for
out.
all of us to have the interaction. We
Yeah.
would never have this level of interaction in a couple years, in 3 years of time, probably.
Yeah. I'm getting a message right now from Caitlin Aarons. Caitlin lives here now in Arkansas, but she's working with NASA, so she's asking if she can be on. She couldn't come on tonight, but she wants to come on some other night, so we'll have her on. But she's been recognized as one of the fine young Americans in this country. I forget exactly which organization had given her an award, but it was an award that was also given to John F. Kennedy. So
That's amazing.
pretty amazing. Yeah, she is a extremely knowledgeable, very enthusiastic young scientist. So really happy to know her.
Yeah.
Yes.
Yeah, somehow I had the PowerPoint set for playing just slide 14 through 14. I have no idea how that happened. Sorry about that. I did not put that setting in there.
Hey, I've given so many sales presentations where things blew blew up completely in my face.
Yeah, I've
Oh,
never
you
had
know?
that happen. I've given 1,000 of these, and I've never had that happen before. So
Yeah. I'll tell you guys a really funny story. In the 1980s, when I was first giving presentations about astronomy, the Rotary Club in Southern California, North San Diego County, had invited me to give a talk about, astronomy and exploring, the current state of exploration in space and stuff. So I had all these slides. I'd collected slides from, you could get them from JPL and from a number of sources. And so I'm so excited to talk to these people. And I have that, that little remote controller in my hand that was tethered to the slide projector. And I was talking about the vastness of the universe. And I throw my hands up in the air, which dragged the slide projector off the podium with all the slides flying all over. The first row. Okay. And I said, and that concludes my talk. It's very hard to recover from.
Oh, man.
Get the slides back in order, or even in the right way. So that was very funny. You can imagine how embarrassed I was.
well, I accidentally did that to a guest speaker one time when we had the slide carousels. And a couple of the slides flipped out, and that was more than a couple. And I put them back in. I was certain I'd put them back in the correct order because of the way they had flopped on the ground. Well, it turned out during the program that they were not in the correct order. And there were these horrible pauses as they reached the slide they weren't expecting. And,
You quickly learn how good your speaker is, if they can roll punches, right?
That's right.
That's right. How well do they know their subject? It's also hard for me to believe we've done 9 of these star parties so far. We're planning on our next European version, which will happen, I guess it's going to be on the 25th of September. So that'll be a Friday. That starts earlier here for us in the States, so that we can capture the night in Europe. And that'll be cool.
How did the one go last Friday night, Scott?
It was good. It was very good. We went all the way from Norway, from Sweden to Australia. So that was excellent. Cesar Brollo faced fierce winds, hurricane force winds, while taking astrophotos down in Argentina. But he was successful. I was really amazed. I was amazed. He actually captured some enough frames to get was it Tucana? Was it 47? I think globular star cluster, and I think it's the second brightest to Omega Centauri. So anyhow,
I wondered how many blocks of concrete he had holding that IXOS 100 down.
Yeah, that's right. It was an IXOS 100 he was using. Yeah. Yeah, that particular little mount has really surprised us and how well it works. We're getting down for the last minute or so here.
Hey, Scott, a question about the IXOS 100. Have you thought about adding a sort of traditional hand controller to that? Well,
we had long conversations about that before we even started the project. Before I had noticed that so many apps and remote applications were going to tablets and touchpads and stuff like that, that I felt that that it was time to move on. But we have tactile buttons that will, with little tiny silicone suction cups, will attach to your tablet and give you tactile buttons. Okay,
Yeah.
so you can move it north southeast, and west, and it costs like, I don't know, $15, something like that.
Yeah, that's my knock on the tablet approach, because it's just, I have to keep looking at the tablet. It's just not tactile.
You'll like the buttons because they have metal tips on them, and you can use gloves. You can use,
Okay.
and it doesn't cost as much as a hand controller would. So we're coming back now. Okay, so we are back, and we are here with our gallery of astronomers. And so, I'd like to take a minute with each of them to let them say where they are, what time it is, and what they're going to share with us tonight. So we've already talked with Chuck. Up next, to my right, at least from what I see in my screen, is Richard Grace, the Astro Beard. And so, Richard, where are you, and what time is it, and what are you going to share tonight?
It's 11:10 in the evening. It's Annapolis, Maryland. We're getting some smoke from the West Coast, haze in the upper atmosphere. I'm taking 2-minute exposures at f10 with a C8, trying to find stars. Very soon, another planet will come up over top of the house, probably in about an hour. So hopefully I will get on that. I had something else planned, but the sky has other plans.
It does, yes.
So
the sky will often tell you what you're going to do. That's for sure.
Sorry about that.
Yeah, the weather said it was going to be clear 2 nights in a row, and I was like, yes, and for the star party too. And like last night, I could see Vega, and Jupiter, and Mars.
Right,
and that was it. I couldn't believe I could polar align. I couldn't even see Polaris, but I could see it through the polar scope. So I got it polar aligned, and it's out there, and we'll give it what it can see. But there's nothing worth looking at right yet.
Okay. All right. We'll come back to you. And then Jerry, Jerry, what time is it? Where are you? And what are you?
Yeah, so we're doing great here at the MSRO. We do have skies. We see stars. So I'm surprised that we do have the smoke. Probably not as much as you do, Astro Beard. But I'm gonna share my screen real quick to see where I'm on with Tyler. Also, he's sharing my desktop at the MSRO. And I've been walking through some things with him, but we're imaging the dumbbell M27 right now. I'm going to share that.
Oh, I see. Wow.
Wow.
Live image coming down, huh?
Yeah. So we got a run going right now but you can see this is the size of the image. That's 1.4 by about 0.9 degrees. So, the system's working great, and we got really good seeing. I think because of the high atmosphere, high clouds, and stabilized the seeing somewhat. So, and you can see we use carte de seal to target. Carte de seal wasn't running earlier. I got it working just a few minutes ago. But we also have Maxim DL, which has a chart program, which is kind of cool. You got the all sky chart, but then when you zoom up, it'll actually bring the image in. Okay, it's just plate solving another image right now, and it'll actually overlay the image. I don't know why. Right there, it was supposed to slew back. Didn't seem like it did that. That's interesting. But the image is in the center.
Well, that's great. That's exciting.
So it overlays the image on the chart for you.
Great. Okay. Well, let's move on to our next guest here. Of course, Kelly Beatty, who we heard from earlier, and Dr. Stephen Edberg, formerly of the Jet Propulsion Laboratory, was on the Galileo mission, Cassini mission, lots of other missions. He's a professional astronomer and a great friend to me and to, I think, everybody here in our group. And and to amateurs everywhere as he operated and managed the Riverside Telescope Makers Conference for many, many years. So great to have you on, Steve. Where are you? You're in California, right? And
Yep, I'm in Southern California. The time is 8:14 here in the evening. And I'm in the foothills of the San Gabriel Mountains, about 1,500 feet above sea level, and 19 miles road miles from Mount Wilson Observatory. And there are a lot of people in this community who are greatly concerned about it tonight with the approach of the fire, the Bobcat fire it's called, that is definitely threatening at this time. And I have not gotten any more recent reports, though I looked to find out what's going on with it. Yeah, you're right. I have over the years, spread my astronomy both professionally and as an amateur. And now I just get to do whatever I do for fun. I tend to be a little bit more of that old school type that we were talking about, where I think it's very good to learn the sky, because, you know, sometimes batteries fail, but you can still point the telescope if you know where to look.
Right.
So, and for those who I just, because you get known to be the expert on astronomy on your block, and people will come to you and then expect you to be able to point stuff out. So it's worth doing to learn the sky. And I was thinking about tonight, I'll probably have more, I will have more in the future to do, but for tonight I just thought I'd keep something simple and offer a couple of challenges for everybody, just because they're, I think, of fairly interest. They've kept my interest up for the past, 15 or 20 years. One of them is to compare the brightness of Polaris. Everybody ought to be able to find that. And Kokab, I should say, which is the brightest star in the Little Dipper. So we're just staying there. And my challenge to you is two things. Which one of those stars is brighter? And you may think that that's an easy question, and I'm going to assure you that it's not. I will also tell you, and it sounds like you have, or at least our smoke is, that of all the West Coast is spreading well across the continent. So I'd wait on this, especially part of this part of the question, and that is, can you see differences in color of those two stars? And I think I have literally spent many years observing them in many of their orientations. You can do it all through the year, obviously, and you will learn a lot by simply paying attention and maybe making a note or just remembering what you have seen when you do that. The other challenge I'll give you is to look in the south now. We're actually going to lose it in a couple of months, but there's still time, and that is to look at Delta Scorpii, what is supposedly the fourth brightest star in the constellation Scorpius. And it's easy to find for most people. Most people know where Antares is. Everything is all right in the south now, so you shouldn't have any trouble right after dark. Antares is the brightest star in Scorpius and one of the top 20 or so bright stars in the sky, big red giant. And to its right, and that's dangerous for me to say, in the Northern Hemisphere, leading it, I will say, are three stars at the front end of the constellation Scorpius, and the middle star there is Delta. And going by the Greek alphabet scheme, Alpha, Beta, Gamma, Delta, it ought to be the fourth brightest star in the constellation. And I'm confident, unless things have changed, I haven't had a lot of clear sky lately, thanks to the smoke, you will find that it is more like, well, I'd like you to find out how bright it is. So compare it to those stars and decide if it really is still the fourth, and keep watching it, because it too has been varying over the last decade and more in its brightness. And actually, it turns out astronomers don't really know exactly what it's doing and why it's doing it. So a little challenge there for everybody. And I can report a second night in a row when I've actually been able to see planets and stars for the first time in more than a week. But Jupiter is distinctly colored red, or well, reddish, turning more red, instead of the bright white that it usually is. And that's thanks to all the smoke we have in Southern California. So I'm looking forward to doing this again with you, and thanks for having me, Scott.
Thank you. Thank you so much. Okay, and so up next will be Rodrigo Zeleta. Rodrigo, why don't you tell people where you are, what time it is, and take a minute to tell us what you're up to tonight.
Scott, in Chile is midnight. In La Serena now is clothing again. But last day I take some picture for the sky. I share with you my screen.
Okay.
Okay.
Let's do that. Let's do that in a few minutes. Okay. Let me get through our group here quickly. I just want to touch with you a little bit. Up next will be Ron Delvaux. Ron, where are you, and what time is it, and what are you sharing tonight?
It's 8:21, and currently I have on my, if you can hear me good, I'm on my laptop. So.
Yeah, I hear you fine. Mm-hmm.
Okay. I have my LX200 here, something you're familiar with, Scott.
Yes, very.
And I have an old DSLR stuck onto it, and be able to show Jupiter. There's 2 moons right next to Jupiter right now. And it seems to be colored normal, even though we are affected by the, the smoke and everything. We've had a northerly wind, just slight, enough to drop it down a little lower. So most of the stars are out tonight right now. Plus, I want to show my 2 old reflectors.
Okay. All right. That's great. That's great. And up next is Steve Malia. Steve, where are you, and what time is it, and what are you sharing tonight?
Hi, Scott. Thanks for having me on. It is 11:22 p.m. I am just outside of Toronto, Canada, in a small town called Bolton, where I have my warehouse and my shop for my company, Ontario Telescope. And tonight, if everything works out the way I'm hoping it does, I'll be talking about the 2 handshakes that help make us see the universe.
Oh, good.
I'll leave it at that.
Yeah, that sounds great. That sounds great. Then up next is someone that's new to our star party, is John Crisp. John is somebody I've met a couple of years ago. I got to meet him in person at an Airstream event that I attended. And so it was great to meet him and his wife. He was a very enthusiastic astronomer, astrophotographer, and aviation guy. Okay. So John, where are you, and what time is it out there?
Yeah, thanks, Scott, for having me. It's 11:23. I'm in the west side of Toledo, Ohio area. I jokingly call my observatory Cloudy Sky Observatory for a reason. So tonight I'll talk a little bit about just inspiration and passion, kind of how those things go hand in hand, and just some life experiences that got me in this hobby and continue to motivate and inspire me. So. That's
awesome. That's awesome. And then up next is Gary Palmer, who has been at, I think, all of our star parties. What time is it out there, Gary?
Hi, Scott. It's 4:23 a.m. and I am in the mountains in Wales in the UK. So it has its challenges.
Yeah.
Yeah. So it's been okay tonight. We've had a bit of mist and a bit of high cloud and that, but we've been imaging away, and we've had live stuff up. I've put M45 back on, so I'll just share the screen quickly on that.
Okay.
There we go. That's coming in live now.
Yeah, you can see the, is it called the Merope?
Yeah, it was spreading out quite a bit earlier with the high cloud coming through, and then it's gone back again. And before the show, I did another test shot with the camera, and this was 120 60-second shots off the imaging rig. So a couple of the stars are a bit out on the image. So this was just a quick process up while we were on the first part of the show.
I see. Looks good though. Looks very good.
The details there, the stars are quieting back down once we get some clearer skies.
Excellent. And then we've got the guide who has brought us to the Clear Skies Network, Dustin Gibson. Dustin, I know where you are. Tell us a little bit about yourself to those. I don't think there's anybody watching that doesn't know who you are at this point, but maybe there's a few.
Yeah, I doubt that's true. It's good to see you though, Scott. I mean, I just popped in for a few minutes, I don't even know how I end up on camera here. I just clicked the button and I was on camera, I was just trying to watch and see what you were telling everybody.
We have a great group tonight. It's we have scientists, astronomers,
for sure,
artists. It's a very good group tonight. So
this program, it's crazy to think that this didn't exist not that long ago. Just weeks ago. I guess months at this point, but still, this wasn't a thing, and I feel like this should have been going on forever. Look at the group it draws. The images. Gary's just flashing images of Pleiades that are just completely next level, unprocessed, and this type of thing didn't exist, where there's just a gathering, everybody talking about this stuff, and bringing a star party to the global astronomy community. I don't know how it gets any better, man. So I just wanted to pop in. I had a few minutes here. We're about to do the biggest product release we've ever done, and so there will be no sleep for me for the next month or so, but
good for you, man. Good for you.
It's fun. It's fun, and we're having a great time. But yeah, man, it's a busy life in California right now.
Yes, it is. Yeah. Well, let's hope that I'm actually looking at. Maybe I'll share my screen so you guys can see what I'm staring down right now. But this is. These are. You can see this is Mount Wilson Observatory, and you can see the glow from fires out there. Off to the right, definitely you can see what looks like flames going above the trees. That bobcat fire out there is really very threatening, and really hoping, this is refreshing every few seconds. That was the blink that you saw there. And so I'm really actually quite nervous that Mount Wilson is being threatened like this. Also, too, I know that Steve Edberg doesn't live too far away from here. So be careful, Steve.
Will do.
Yeah.
No evacuation warning yet.
Okay. Well, that's great. Stay safe. Okay. Next up is Craig Bobchin. Craig is an old friend of mine. Someone who is also a fan of I'm still a fan of the ETX. And so, Craig, tell us a little about yourself, where you are, what time it is, and what you might be sharing tonight.
Well, I'm in the same time zone as you, Scott. It's 10:28 here. I'm in San Antonio, Texas. Just recently relocated here from Southern California. I know Steve from many RTMCs out there.
Mm-hmm.
I know Gary from way back as well. And I don't really have anything to share tonight. This is my first one here, so I'm just trying to figure out what it is. And I have some ideas of what I want to share in the future that I'll talk to you about.
Oh, very cool. Very cool. That sounds great. Well, you're welcome to hang out as long as you like. So that's awesome. Next up is Caesar Brolo. Caesar, you were blowing away in the wind at our last star party. How are you? I think you're muted, Caesar. I don't know why. We can't hear you. I don't know. No audio. Oh, wait. Not yet. Nope. I'll tell you a little bit about Caesar. He's down in Buenos Aires, Argentina. And he is, no, we don't hear you, Caesar. He is with Optica Sirocco, which is an astronomy telescope dealer down there. Did I hear you, Caesar?
Now?
A little.
Can you hear me?
Yes, now we hear you.
Ah, okay, okay. Yes, it's a configuration, some problem of configuration of. Come on, yeah, yes. For me, it's a mystery sometimes.
Yes.
Because I wasn't unmuted, but yes, I had the wrong microphone.
Yeah.
Well,
Now, Caesar, do you pronounce your name Cesar or Caesar?
Caesar is perfect in English. Yes.
Okay.
Cesar is in
Cesar.
Cesare in Italiano.
Okay. All right.
Italian, yeah.
And you
many people call me.
Yes.
Ask
In
me,
Argentina.
yes, many people ask me like Cesare in Argentina
Mhm.
because it's yes, maybe they have something of Italian, maybe not. I don't know. And well, here it is at 0:31 in Argentina. It's partially cloudy here. I'm trying to point Jupiter by the cell phone. I'm trying this, and maybe if in a little time more, we can get the opportunity of have a mostly clear sky. We can try some picture of the deep sky. Maybe we can try again with the 47 Tucanae or any object. No problem. I am ready to make something. But in this moment, we have a 50% of clouds.
50%. Okay. So this is how we're going to do this, folks. We're going to let the person that is up the latest go first, okay? And the winner of that, of course, is Gary Palmer because it's early in the morning there. Okay, so we want to let him make a little presentation, spend 10 minutes with us, and give us an overview of what he'd like to cover. So, Gary, we're going to give you the spotlight. Here we go.
Thanks, Scott. It's me knocking everything everywhere as I moved in. Right, if I share my screen up, I think we'll put the image up that we captured earlier and actually run through some of the processes on that for 5 minutes, because that would really tag on from where we were on the last star party, if I remember rightly. Maybe just go back a couple of steps and okay, just get myself back in order. Okay, so what we've done with the image so far is, and it did take quite a long time to do this, was to stack as I showed in the processor, I think on the last star party. So that's the image that we've got at the moment once it comes out of the stack. And we've also done a dynamic background extraction. Just going to drop that down as well, so it's out of the way. The dynamic background extraction removes a lot of the casting that you get in the background on the image. And then we're ending up with this. And when you look at it, it is quite green. You can see some of the fainter colours on the stars, but you do have to remember that this is a test image. We had a lot of cloud running through earlier, and we just literally left the camera running to see what we could get. So we need to colour calibrate it. One of the best ways to colour calibrating this is using the photometric colour calibration system. And it's nice and straightforward. I'll just move that second. There we go. Okay, so we need to acquire the data for the image. So if we search the coordinates, we've got it typed in there. When we hit search, it'll come up with all of the relevant data of the color of the object. And we've got that. That's all in. And we're acquiring the time and date of the image from the actual image itself. The main thing then is the focal length of the telescope and the pixel sizing on the camera. So once we've done that, we can apply that to the image. And it doesn't overly take long. It's a very accurate way of color calibrating the image because it's taking it off of data that's already held on record for all of these different objects. The amount of time it takes is always down to the speed of the computer. There are a couple of other ways of color calibrating the images, but it really depends on the type of system that the type of images and what filters you might have on. All of these different things make a difference. This image is taken with no filters on the system, so it's literally the camera straight onto the telescope. A couple of seconds, it'll be done. Once we've done that, we need to look at some noise control on the image. So there's a couple of different ways. I generally use a wavelet system to remove any background noise in the image. Other people go in and do different other ways around it, but my general ways is to do it like this. So I said it would take a couple of seconds and it's taking longer. There we go. So we'll re-brighten the image back up. And now you can see we've removed a lot of the green cast in the image. And if we look at the stars, you can see the blues around the stars and the yellows. So to do the noise control, I'm just going to close some of these up. I generally use MLT, morphological transformation. And then all we do is we make a mask to go over this. This is to remove this background noise here, and that's quite common, certainly when you're not using filters. And also, you might not have got the gain levels correct when you do these tests on the cameras. You have to play with them for a few nights to get them how you want them. So you can make a nice simple mask. The mask has to be stretched though to use it. So all we're going to do is select that mask in the histogram, reset the histogram, and then we're going to brighten this image. And we're going to copy that into the histogram. So we're going to use that. And then transfer from the histogram back over to it. And that now is a permanently stretched mask, which we can use. To apply the mask, drop it on the edge underneath the name, and then we're going to invert it, so that it's working on the back. Multi-scale linear transform. Now I've already got these preset in here. I generally go 3, 2, 1 and 0.5, but I always do the percentages, the amount at 50%, and then we drop that onto the image.
People are liking your image processing, Gary. They love
Excellent.
Yeah, they love this.
I hope it helps some people out. It's not an easy program, this, and I always say with every single process here, there's probably 300 ways of doing something. So everybody's got a slightly different way. I always look at mine for ease. I've got to come up with things quite quickly quite often. So if we go backwards and forwards on that, we can see the noise in there. We need to remove the mask. There, just to stop that. Okay, and then we can remove that. And then we need to stretch the image. There's a few different ways of doing this. I, again, will make a little preview box somewhere in the darker area, somewhere over here, that's out of the way of the stars, and you can use Alt-N to do a quick preview. Just a tiny little box in there. And then we're going to use mask stretch on this. And one of the reasons for that is we don't want to overstretch the image. We can always adjust it later. So we can use mask stretch and then just check we got the correct preview and apply it to the image. This will give you a good balance to work with. So if you were a little bit high on the game with this, the camera or your ISO, if it was a DSLR, then we can control the stars a little bit better. That's the key thing. I mean, a couple of these stars here look a little bit like crosses when you look at them, and that's just a high cloud going through on the image. And then what we'll do is, once we've done this, we'll add some color into it, and that'll probably be it for this particular star party, and we'll continue this on with one of the next star parties.
Gary, I have a question for you. A lot of people here have tried to use PixInsight. Tim Myers is saying, I tried it and it kicked my butt. Shifted to APP, but I'm rethinking that decision. You show people how to use PixInsight, right? With your classes, your astrocourses.co.uk, right?
Yep.
Yeah, I'm going to put the link in here.
Yeah. We do all different software, so it's not just PixInsight. But as we've said before with, okay, so that's the image stretch there. So it might look a bit dull now, but we've actually got the stars a lot tighter and the image is looking a lot nicer. One of the things is quite often people don't want to pay for software. They want to use free software like Deep Sky Stacker and some of the other things that are around. We teach really whatever somebody wants to learn. So earlier I was doing some testing. I was using AstroArt, or you can use Nebulosity. There's lots and lots of different software out there, Astro Pixel Processor. But a lot of people don't, they find PixInsight quite hard. But you have to understand the power of the program. And really what I come across with is, if you spend over $1,000 or £1,000 on the equipment, then you really want to start looking at a good piece of software to process your pictures. Otherwise, you're hitting your head on the brick wall. Is way to put it.
What would you say from all the people that I imagine you get? A lot of people are ranging from beginner to advanced, but what are the top 3 questions that people ask? I put out there, feel free to ask questions, and people are just going, gosh, I got a zillion questions, I don't know where to start. But what do you see? What are the top 3 questions that
I think it's running things through the batch processor at the beginning, or the weighted batch processor, as they're now asking you to do. And to give you some idea, I've got a real big processing computer that we're doing this on.
Okay.
I ran this set through the new weighted batch system, and the problem with that is where it's reading and measuring now. It took an hour and a half for it to put these together. Not this particular set now, but one of the sets that I did a couple of nights back was an hour and a half. So it does seem that as we advance along a little bit, that we're taking more and more time, but we're getting a more and more precise image that's coming out the other end of it. And you're needing to do less work in other programs. So the batch processor There's always arguments over whether you need bias frames or not. I tend to use them, although this particular set hasn't got them on because I haven't taken them yet with a new camera. So it's darks and flats. But there are a lot of arguments over whether we should be using bias. I generally find the software works better with them. The others are really just really a workflow as to how to get moving along in it. And as I said, with each process, so some people will go the simple route, some people will go really, really complicated routes in it. And you can go right into your maths with this, and you can do the pixel maths, and you can add percentages of images together and all sorts of things. It's how much time you want to put into these.
Yes. Right.
So the last thing we're going to do on this, all I've done with this now is I'm just darkening this a little bit so that we're going to use it as a mask, and then we're going to use that to add color in. So we just darken the background and do exactly the same process again, of adding the mask on. And then we're going to use curves transformation. And I'll reset that, click on the image so it's active. When you click on it, the surround goes blue. Yep, so you know it's active. And also, if your mask is on there, the name bar turns orange. So we're just going to stick up a live view there. And then we're going to adjust the saturation side. So normally when we first, if I reset that and put that back to here, it comes on like this. What we would need to do is select the saturation. And then we're just going to bring in an amount of color into the object.
Somebody just asked, are you using weighted batch processing? And I think you just went through
I
it.
didn't on this. I didn't have enough time with the show. We'd still be now waiting for it to run through this. So this was just done on the normal batch processor.
Right. Okay. All right.
So once that's done, we've still got a little bit of green in the image just because it's imaged with a color camera.
Yeah.
So we'll use the STNR.
Beautiful. Beautiful image of M31. Very nice.
We can just take this now. And this is about halfway through the processing now.
Yeah.
So it's not sharpened. We would deepen the color some more in the stars and actually remove some stars now at this point. So but anyway, that will do for now. We'll continue this on the next star party.
Okay. Sounds good. Sounds real good. All right. So we will take this back to grid view here. And I believe that probably Cesar is the next one up here, because I think it's latest for you at this point. So we're going to give you, let's take 10 minutes and learn more about what's going down in Argentina.
Yes, okay. Well, now I trying to point Jupiter, but every time that I have in the screen, well, I have a cloud moving, but a few minutes later. But here I have the preparing the cell phone attached with the eyepiece with a laptop.
Okay.
Using the Exos 100, it's possible. It's possible to point maybe in 5 minutes more to have something of Jupiter. Something that we can do it is I'm connect again when I have the image of Jupiter in my cell phone. I connect to the Zoom with the cell phone. I change or I use again the code, but I'll visit by chat, of course.
Okay.
But it's not easy today because I need to change in another mount. I change. Okay. I started using this setup, the same setup that I used the last Friday in the European edition of the
Star Party.
Star Party, Global Star Party.
Yeah.
You remember, yes, embarrassing adapter with wood that they use. It is real. Okay.
Cool. I like it.
You can see that this is real. Yes.
Yes.
And in this type of mount, the Altazimuth mount, I found that have a slide now, and I changed the setup to this camera to make something for deep sky. Of course, that deep sky in the city is something that more imaginary, but it's possible. And here will be have Jupiter when the clouds moving a little more, but because it's going to be clear the night.
Sure. We'll go to someone else and then come back to you and see if it's cleared off for you. Okay?
Sure, no problem. Yes. Typical.
Yes.
It's a star party. Yeah.
Star party. That's right. Okay. Thanks, Cesar. Okay. So who's up next? Who's on the East Coast here? I know that Jerry Hubble is out there. John Crisp. John, what have you got for us?
All right. Well, thanks, Scott. Again, I appreciate you letting me participate in this event. And for me, I hope to be able to do some more of this and try to get to be involved in the community a little bit more. Just a little bit of background on me. I'm a vice president of digital technology, and my goal, and I talk about it a lot, and Scott and I were talking earlier today for the group, that what I do is try to inspire, whether it's my aviation or whether it's my astronomy or photography. And so I'm going to share my screen, just take you guys through a little bit of some of the things that I think kind of lead down that path of inspiration. And so for photography and aviation and astrophotography, as I mentioned, if I can inspire one person to look at nature or the world in a different way, then I've accomplished something important. And then if that person picks up that passion to create or experience something, then that's even better. And a little humor here, being outside of Toledo and certainly not as far north into Canada, but buy a telescope, try long exposure astrophotography. It'll be fun, they said. This was, I think, a 0-degree night where I was outside with my telescope. So you can get a little idea there of the commitment it takes sometimes. Here's my setup. So I have a sky shed pod in my backyard, and fortunately an understanding wife and understanding neighbors. Every one of my neighbors were all in on this project. I include them. That's about the extent of the outreach that I've been able to do. I have a very busy job and career, and that excuse kind of keeps me from traveling as much as I want, but it's nice to include the neighbors, and they certainly appreciate the pictures I take. And I really like the shot of the Orion Nebula coming up over my dome there.
Yeah.
And as Scott mentioned, one of the other things about me that takes a lot of my time and energy is certainly a mistress in my life and a passion is aviation. And this is a Fokker triplane that I built over a 10-year period of time while I had a career. So it took a lot of effort, but I always call this shot kind of the ultimate selfie. But this airplane is unique in that there aren't many of them in the world anyway, very few flying, and to be able to really document the journey of flying this airplane, building it, documenting what it's like to fly it, how hard it is to fly and land, and then the kind of a little side story talking about the passion. This airplane just about killed me on the second flight. Power failure on takeoff, went down, landed upside down in a ditch. Fatal event 95% of the time. And that really, I already had passion, but that kind of takes it up a notch. But aviation, along with astrophotography, is a passion. And so we've talked a lot about what gets you down that road in our lives, I think, amongst each other and the world. But it takes little things that can really kind of drive you down that road. And then the big things like a crash can really sit back and, take you down the road of what's really important and where are your priorities. And astrophotography has been one of those, and that's kind of wanted me to do more of the outreach like we've talked about. And inspiration, these are some of my early images. Looking back, it was kind of a fun journey for coming on tonight, of looking back through my feed of what my pictures have looked like over the years. And this was kind of the start. Here's where I am today, those same images, well, kind of along that path. It's funny, I've already learned something tonight I can apply to my M31 shot there. But posting pictures like this for me and really getting people to understand how fragile life is, which I can, talk from firsthand experience, to the beauty of the world and what's available to us. Kelly mentioned it earlier. There's so much technology in our hands today. It's very affordable. You don't need a lot of money to get started. I had an 80 millimeter Tasco refractor from Service Merchandise that I saw the rings of Saturn through, and down the journey, the path you go, right?
Right.
It doesn't take a lot. And, for me, again, to show pictures like this to people that, my neighbors or whoever it might be, it's always inspiring. So just a few more shots, and I won't spend a lot of time on these because, down the road, certainly like to talk a little bit more about what my processing and things like that are.
Sure.
But, it's beautiful. And so not only do I do the astrophotography, but aviation photography and landscape photography is another passion. And I spend a lot of time in that world as well. So talking to the group that was on earlier, they're not on now, I guess, but Kelsey, being in the aerospace industry, that was certainly for me early life experience as well. I got to fly an airplane on my 8th birthday. Bob Hoover took me for my first airplane ride. My dad built the B-2 bomber. He was the lead manufacturing technology engineer on that project.
Oh, that is cool.
Yeah, Scott, you and I have talked a little bit about that, but
yeah,
this airplane, I got to see it before it was official, as it were. I was in the Air Force and ROTC at the time, and this airplane put me through college. My dad was out in California.
Yeah, an amazing aircraft. That's amazing.
It is, and to see it, to see it fly, it's just talk about futuristic. And then I saw today the Air Force has been testing a next generation fighter that they released some pictures of, which is pretty cool. And again, just traveling to try to get up to dark sky areas up. We fortunately live not too far from the Upper Peninsula of Michigan, where we do get some beautiful skies, and again, be able to go up and do long exposure or night photography is one of those things that I love to do. There's a quote from Winston Churchill. I'll paraphrase it so I don't misquote it, but basically somebody asked him why he only did landscapes, and when he painted, and he said, trees never complained about how he rendered it. That's why I don't do portrait photography. I like to shoot in inanimate objects. A couple of shots that I put up here, the Rosette and Eagle. What's interesting, Scott, on the Eagle, I think I've mentioned this before as well. That's shot through my David Levy Comet Hunter.
Oh, right.
Love that. That's a cropped in shot a little bit, but hydrogen alpha. But I love that scope. So it's one of the scopes in my collection. Again, just a little bit through what pictures I like to post and share that try to inspire people to put their phones down and look at the beauty of the world. For me, the airplane, the joke with my wife is she says every time I open the hangar doors, I hear angels singing. I always say, no, it's the theme to Top Gun. But the little star trail shot over the observatory there on the bottom left. And again, just a few random shots of just different locations and things that interest me. Neowise was a frustrating adventure for me. We had it out. It was visible several times. It was visible from my observatory. However, you can see the clouds. We got really no clear nights to really get some good shots of it. And with work and with COVID and everything, I've been very busy and didn't get to travel. I would have loved to have gotten into a better clear sky shot area for that, but still was able to get a few images on it. As well. And again, just some of my aviation photography. People ask me frequently if I would, sell pictures or, put a gallery out there. I don't. Anybody who wants a picture that I take, I provide it. I give them the raw file if they want it, a processed file if they want it. I'm still learning. I'm not a professional by any means. I just, like to take the pictures, and so I'll give anybody any of my pictures that I take if they want them. Because again, I try to get that inspiration and those passions and it's sparked in other people. And then I'm wearing my Devil's Tower shirt tonight. That was another one of those moments in my life, seeing the movie Close Encounters.
I just watched it last night. I watched it twice last night.
Oh, did you? I love it. I watched it just about 2 weeks ago. I was able to I didn't put them on here because I didn't have time today. I got interrupted at work, but I was processing. I did some great long exposure night shots out at the monument. We were only there for one evening, and it rained for the first, I don't know, it's about 2 o'clock in the morning. And I got up from the hotel room and I told my wife, if I can see Jupiter, then I'm going. And we were staying about 10 miles from the monument, and it cleared up enough to go get some shots. Maybe on another show I'll share that. But that's just a little bit of my story and a few of my images, and I really appreciate the company that I'm in tonight with the group on the call and the people watching, and certainly love to be able to do more and get to know you guys a little bit better and kind of go down this journey together, because it's always more fun when you've got people to share your life with and create those memories, because that's what really matters at the end of the day.
I couldn't agree with you more, John. Thank you so much, man. That's great.
Yeah.
Well, we're going to go to Rodrigo Zeleda. He's down in La Serena, Chile, and he's got some images that he was able to make, and there we go. Okay, so Rodrigo, we're going to put the spotlight on you, and then we're going to take about a 10-minute break after Rodrigo. But before we go, we'll have Chuck ask the second question of our 3-question series for people who want to win door prizes. So here we go. Here you go, Rodrigo.
Hey, Scott. Good night. I shared with you my last photo for the Sun and the nebula in the little galaxy Magellan Cloud, the SSM galaxy. Okay. Do you see my screen?
Not yet. It says double. Oh, now we do. Yes. Yes.
Okay. This is the sky in Chile now, in the south, and here is the Magellan Cloud. In this galaxy, near or the Milky Way, I take the picture for the principal nebula in here. This is a simulation with Stellarium.
Oh, wow. Okay.
Okay.
Yes.
Now my picture. Okay, I changed the view. Okay. You see my screen now?
Yes.
Yes, this is my picture for the Little Magellan Nebula, so a galaxy, and this is a small nebula is a extragalactic nebula in Magellan Cloud. This is NGC 346.
Wonderful.
This object. This picture I'm taking with the Explore Scientific FHD 100 telescope with focal reduction or more Wi-Fi. The object is very big in the sky. This sector is the galaxy, and this is a cluster and a nebula in the galaxy. This is this galaxy in the southern hemispheres, like Chile or in the south. I see the Algiers. I see the galaxy surround around to the South Pole. And this another galaxy I take picture is a very famous galaxy, the galaxy of Sculptor constellation is NGC 253.
Yes. Now, Rodrigo, how do you process these images? Are you using GIMP to process, or?
No, GIMP is only for show these images. I process with PixInsight.
Oh, these are processed with PixInsight. Okay.
Yes, I show is more easy for me showing GIMP, but my process in PixInsight. This photo is with RC telescope and 3 hours of exposition. This is my picture tonight, Scott. I hope you like them.
Awesome. Beautiful work, man. Beautiful. Yeah. Congratulations. So thanks very much. Thank you. That's great. And so let's look back towards Cesar. Have you got? Did you get clear skies out that way? Yeah.
Yes. We can try if we can turn the camera. We can try in another connection to our Zoom. Sorry.
Okay.
Yeah.
Okay, so let me, so you're...
I have a cloud now, but it's a small cloud. I hope that it's moving,
Okay. All right.
I'm proud, yes.
And this is, okay, I see you on the other one here.
Yeah.
Okay.
I turn another camera. Let me check. Work.
Isn't it amazing what we can do with these?
So it's so easy because but I need only to okay.
Yeah.
Well, first of all, yes, and let me check if okay. The first problem that we have is that it's unable to it is very interesting. We never use Zoom to show Jupiter from the cell phone. But the first problem that we have is that it's unable to use the Zoom or change the light.
Right. Yeah, but I can see that you're getting the data. Okay. Yeah. And so I can show back again here. So this is I see a little bit of haze around it. Is this some of the high clouds that you were?
Yeah. So you have two satellites here. I don't know which is.
And I see some moons. I see some moons around Jupiter. Mm-hmm.
Let me check which ones, because one of these are near of a transit or occultation. Let me check. I think that the closest is Io IU, or I don't remember in English how you say. And the another one
Right.
is Europe. Something that is interesting is that I make and I couldn't make a go-to alienation. Only I put the mount, and the tracking is acceptable. It's good, but I could by the clouds I couldn't make a go-to alignment with 2 stars.
Okay.
But if you, I lost where is the Jupiter now, but it's in the center.
Yeah, and if I'm looking at your screen, it's
Yes, but it's a close. Yes.
okay.
Yes.
Mm-hmm. Okay.
Well, I'm sorry. No, the problem is that normally I make with the fingers. It's very easy to make the zoom. That is perfectly to watch everything.
Sure.
But I am record a little video. I am put in the computer and I'll show you in a few minutes. No problem.
Sounds good. Okay.
Yeah, this is the only thing that I can do it now.
Okay. No problem. No problem. All right. So Richard Grace, I know that you've got some images of Mars there. Steve Malia, you're in Canada. What time is it getting to be out there?
It's just after midnight. It's about 12 after 10.
So that
10 after 12.
you got a long day ahead of you tomorrow. So why don't you share what you're going to?
Okay. Do you want me to go through it now? Is that what you're asking?
Yeah.
Okay. All right. I can do that.
Keep you up too late.
Okay.
Trying to be sensitive here to people's time.
I appreciate that. I'm probably sharing the wrong screen. Hold on a second. All right. Can you see my screen okay?
Yep.
Okay, great. So I like to call this the 2 handshakes that allowed us to see. This was inspired by a podcast that I listened to from Mike Rowe. If anyone's watched Dirty Jobs on the Discovery Network, Mike Rowe is a host, and he has a podcast called The Way I Heard It. So I thought it was pretty cool, and I did a breakdown of it, and I presented this to my club about a year ago when we were allowed to all get together and meet. So this is the 2 handshakes allow us to see it. So before I get into that, there's something called the butterfly effect, a very small event that can create a much larger event. Butterfly flaps its wings in Brazil. We get a hurricane in Florida, type thing. Here's an example. Do we know who this guy is? If you know, don't say, right? So this guy, who would have hired him, right? And ends up being the great Steve Jobs, right? Who I've always admired. Here another great example. Anyone know who this guy is? And we get this handsome fellow here.
Wow.
So this is the Hubble Space Telescope, as most of us know, and people at home that are watching this on the various social media networks probably know as well. It's been up there for quite some time. We've seen some amazing things with it, and it has actually a pretty cool history that dates way back before there was even a space program. The idea of having a space telescope, telescope that is above the atmosphere to get the best images we can get. But technology didn't allow for it at the time, but they still worked on it quite earlier on. So with Hubble, we've seen some amazing things with it. Some fantastic images, right? I love these. These are really good. Probably one of the most famous out there is this, the Pillars of Creation. And I think this is what kind of saved Hubble, the Hubble program, when they introduced this as it's coming back after it was fixed. And get to that in a moment. But this is probably one of the most famous images that exists, the deep space field. And I saw Neil deGrasse Tyson speak. He came up to Toronto. The Dunlop Institute had him up, and he showed this. And he said, if you take a good look at this picture, there's only 3 stars in the entire image. Right? And everything else, every little speck that you see there is a galaxy. And
there's only 3 stars in this field.
There's only 3 stars in this field. There's one directly under the P in telescope. There's another one about halfway down under the H in the. And then under the first E in telescope, if you go down about 3/4 of the way, there's another star there. And you can see that has the spikes on them. Oh, no, it's 4 stars. Sorry, there's another one. So it's 5 stars, 6. Okay. Doesn't matter. There's only a few stars in this whole field. And everything else is just galaxies. So, maybe there's life out there somewhere. From our earlier conversation we had before the show started, who knows what could be out there and what's looking back at us. So when Hubble went up, this is what we got initially, and we before those great images, this is what we got, and it wasn't really all that exciting. Right. And
but it showed that the cameras were working, right? And that
well, absolutely. So then they found out what the problem was, and a flaw in the mirror, and then how it was created. And I've heard a few different reasons why it had happened, but it happened. So I'm gonna take us back to back in time a little bit. But this is one of my favorite cities in the world, San Francisco. I have a lot of history there. My wife and I were engaged in San Francisco. We went back shortly afterwards. We've taken our kids there. Absolutely love the city. A lot of fun, great place to be, excellent food, San Francisco. So, the Painted Ladies, right? This is the Bay Bridge.
Right.
Right. There's the Transamerica Tower, the famous Golden Gate, California Street, right? I can picture that Mustang racing up and down right now, right? And then Coit Tower. Picturesque, all postcards, beautiful city. I love San Francisco. But just over 100 years ago, it looked a lot different. And actually, when pictures are coming out today, it looks a lot different too. So the Great Fire of San Francisco in 1906, a lot of devastation. And this is where our story kind of begins. That helped us see. So a lot of devastation. The city was just flattened. The percentage, I can't remember what it was very, very high amount of the city that burned down. Interesting fact, they wanted to build the place up so quickly that they actually took the code book and they threw it away. And they said, just build, because they wanted things to go up fast. So some of those buildings still exist. So if anyone's looking to buy real estate in San Francisco, get a good home inspector. So while all this was going on, there was a gentleman that had a bank called the Bank of Italy, and there was people in the streets. There was pandemonium. People were scared, running around, and we have this gentleman, Amato Giannani, and he founded the Bank of Italy in 1904. But he had a problem. He had $2 million in his vault that he had to get out because he was afraid that he was going to be looted, and he didn't want to lose that money. So he's out on the streets, and he made some arrangements with a gentleman who actually came into town. He had a farm, and he would pick up people's garbage, their food scraps or waste and stuff like that. He'd take it into his cart, and he'd take it and bury it into his farm somewhere, natural fertilizer. So he made arrangements. He said, "Hey, come here. I need some help. Can you help me get this money out?" He just said, "No problem." They took the $2 million and they buried it under the trash. and nobody would suspect a thing. They got on the buggy and they just carried out of town.
$2 million buried under a garbage.
Yeah. Right. So, and what was really good is that Mr. Giannani was able to go back to San Francisco shortly after that, and he set up, as you can see here, it's a bit of a cartoon, but he set up 2 barrels and a plank of wood down at the wharf, and he gave out loans for people to rebuild and for businesses to get going again. And this was really important because no other bank was able to do this at the time. And he was able to give out these loans for people to rebuild. Now, Mr. Giannani was so indebted to this gentleman and so grateful that he said, name your price. What do you want? Right. He said, I don't want anything. Right. But when my son is older, can you please help him out with a job? And he said, when your son is of age to work, he will always have a job. That'll never be an issue.
Right.
Mr. Giannani, his Bank of Italy actually became the Bank of America. And that gentleman was the grandfather of this gentleman, Frank Seppi Sepulina.
Okay.
Right. And Seppi, in 1984, developed systems, right, and pressed his bosses to repair and not walk away from disabled spacecraft. And he went as far as to tell the press that the Solar Maximum satellite back in '84 would be repaired. Even though he didn't get approval, he said, we're going to repair it. So he developed satellite servicing techniques and actually influenced spacesuit designs starting from Gemini 9. So because of that one handshake that took place in San Francisco, Mr. Sepulina's father was gainfully employed from it and was able to provide a life to Frank so that he can go on to do what he wanted to do, become an engineer, and he went on to work for NASA. This is actually a pretty fascinating story, and you can Google it or use Bing, whichever search engine you want, and you can read up on Mr. Sepulina. It's actually quite interesting. So there's an image there of a Solar Maximum, and he developed that second handshake, right, to capture Hubble when it needed to be repaired. And Scott, your good friend, Mr. Story Musgrave, was the astronaut in charge at the time that went up and did that repair. Right? And now things are much better.
They are way better. Yep.
So thank you very much, Scott, for giving me the opportunity.
I like that. I love that. That's cool.
I thought it was a pretty interesting story, something that happened long ago and the influence that it had on a couple of individuals' life, and then the impact they had for us to be able to see. I'm sure they would have fixed it eventually, but I think that the way that it was done was pretty cool. And the small event that happened over 100 years ago that came out now is just to me it's one of those things like, wow, that was close. So anyways, Scott, thanks. This was the presentation I wanted to give last week, and I had to scour a few different computers to find it.
I love it. Well, thanks very much, Steve. Thank you.
Thank you.
All right. Have a good night.
You too, Scott. Have a good night, everybody. Thanks for having me on.
Thanks. Okay. All right. So let's go to Chuck Allen for our second question of the night, and then we'll take a 10-minute break, and then we'll be back after that. And you got the spotlight, Chuck.
All right, hang on. This time I think it'll work. There we go. Scott, I'd like to start, if I may, before giving the second question, with just 1 minute comment. Back in 1993, I came up with the idea of a National Young Astronomy Award for the Astronomical League. And we lost our sponsor after about 2 years. And Scott jumped in and has sponsored this award now for, I think, the better part of 3 decades. And it has been an award that has really rejuvenated the youth participation in the league, and we're very thankful for Scott's support. I had the privilege to judge 7 international science and engineering fairs in Earth and space science. And I can tell you that the projects that we're seeing submitted today for the National Young Astronomer Award are every bit as good as the ones that I saw at ISEF. And Scott, just publicly, I wanted to say thank you for everything you've done for us over the years.
Chuck, your vision and inspiration is something that I constantly think about, and it's been an honor to be part of this. So thank you for allowing us to be part of this.
Well, thank you.
Hard work and vision that it happened at all, and and wow, what it's created over the years, and the effect it's had on these young people's lives. So big, my hat's off to you. So thank you.
Well, thank you. And question number 2 for tonight. Who was the first person known to have sketched and noted the movement of the planet Neptune?
Okay. All right, so you're going to send your questions to Kent at explorescientific.com. Don't answer them here in chat. But who was the first person known to have sketched and noted the movement of the planet Neptune? That's cool. Is that the original notes for it too?
That's it.
Chuck, I love that you're into this history of astronomy. I was looking at that porch where Charles Messier, photograph, and I was just trying to imagine what it was like to be an astronomer back at that time. So.
And stand in that porch.
Yeah.
And I had to beg my way up there because that porch was off limits at the time because, as I mentioned earlier, construction. So I'm trying to persuade this lady in French to let me up there, and it took a while, but they finally relented. So
that's so cool. Very cool. Okay, well, we are going to go to a 10-minute break, and we'll be back for the wrap-up of the Global Star Party number 9, and we'll talk a little bit about Global Star Party 10 that will be coming up as well. So we will. Let me just share my screen here a little bit, or maybe I don't even need to do that. We'll just jump to this, and we'll be back in 10.
Can you hear me, Tyler?
Yeah, I can hear you.
Okay, I can hear you now. I don't know if this is going over the air. It might be.
Yeah, it's open.
Okay. So Tyler's been with me on the MSRO this whole time. We've been working together.
You guys getting images?
Yeah.
Oh yeah.
Cool. Okay. All right. So let's see. So we need
Is it going to process them live on the show, the images?
Yeah.
Not that good yet. No.
We need to get to Richard Grace and then and the guys.
So we didn't have this. We didn't have the sky problems that Richard said that he was having with the
Really?
smoke.
Yeah, Richard, how's your sky doing so far?
A little better than earlier. The flow of everything is just north of you, Jerry. But
yeah, I was wondering about that.
I got a pretty good looking Mars. Occasionally, when it stops moving around too much, you can see polar ice cap and kind of tell where Olympus Mons is.
That's very cool.
That's awesome. That's hard to do.
Well, I've been looking at it for like an hour, so it doesn't mean everybody else will see that.
For anybody listening to this, you guys in the audience out there, if you want to participate on the Global Star Party and join in, you can either get a no charge ticket if you go to explorescientific.com/events, or you can contact us directly and we can talk about what you'd like to share with the audience and have you join us. So it's always fun to have people come in. Caesar, are you getting some sky out there? Can't hear you. I don't know why. No audio. Yeah, hand in the mic, Richard. That image, those images of the galaxies are beautiful from Rodrigo. Space Time with Robert. He says, heck yeah, I'd love to join this. All right. We'll have to have you come in. So, Robert, all you got to do is you can email me at s@explorescientific.com, or you can go to, we do these every Tuesday night at the same time. Although when it gets closer to winter, we'll probably scale it back so it happens a little bit earlier for everybody. That would be nice. Yeah, you can go to explorescientific.com/events and buy a no-charge ticket, and we'll let you in. Jeff says, with any luck, I'll be able to start imaging next month. Book Davies says, off to work. I'll see you all next time. Wherever you are, Book Davies. I think you're in Europe somewhere. Guy Dude says, anyone know if Explore Scientific's coming to the El Dorado Star Party this year? I don't think so. I don't think that we'll be traveling due to COVID and the pandemic to any of these star parties this year. It's really, I have a responsibility to keep the company running here, and I can't try not to be putting myself at risk here. Okay, so we're back. And let's see. I think I might still be spotlighted here. So I think that we're back with our group. And we have Ron Delvaux, Richard Grace still with us, Cesar Barolo, Tyler Bowman, and Jerry Hubble still working away. And Richard, you had I think you had Mars in your telescope live. So let's check that out.
Yeah, man. Get the screen sharing here.
Mm-hmm. Oh, goodness. That's a nice view. Look at that.
The polar cap's up here.
Yeah.
And Olympus Mons should be right there.
Oh, wow. This is excellent. So everyone...
Also the only thing in the sky that I seem to be able to get right now.
No, it's good. It's good. Beautiful. I like to see it. You know, it's not in complete full phase right now. You can see kind of a gibbous view of Mars. I don't know if that is an orographic cloud out there, but over onto the kind of the 1 o'clock position, it looks like I see a white patch pop in and out every once in a while.
Yeah, I'm definitely seeing this white patch right here.
Ice cap. Mm-hmm.
Yeah. Oh, you're talking about over here.
Yeah, you see that?
I am also oversampling, like way oversampling. I'm using 2.4 micron pixels on 2000 millimeters of focal length, which is a no-no as far as the calculator says, but it's what I got for the moment. So
beautiful. So what are you doing? Are you capturing a bunch of images right now? Is that
yeah, we got 100 millisecond exposures. I got the gain just, you know, a fifth the way up just so I can kind of move it around, because as it gets a little higher, it gets a little brighter, a little less atmosphere to look through. And so I've just been tweaking it a little bit. And I figured after we did the live thing, I'll get a few more captures on it. I got a few already. I'll try and make up some video, because I've been looking forward to getting Mars here with the coming opposition. And I'm also looking forward to the Halloween Uranus opposition, because that was one of the first things that I ever tried, and now I have a little more power, even though the C8 can be a little testy sometimes with the long focal length and stuff. Plus, it's used, so it's probably 25 years old or so, but it does an amazing job, and
it's doing a great.
It was a good used purchase for me. It's one of my cheapest telescopes.
Awesome, though.
Yeah, put a Losman DD plate on it just to make sure it's, you know, good and locked down, and we're using a IR UV blocking filter to try and eliminate some of the fuzz around the planet there a little bit. And I'm using a Crayford style focuser screwed onto the rear cell of the C8, because when I focus with the primary mirror, I mean, it'll shift a planet clean out of frame almost sometimes. So I have to, I usually put the Crayford about halfway in the middle of its focuser, and then I focus normally, and then collimate, and then only move the Crayford at that point. That way I'm not having the primary mirror move the image shift and all that stuff.
Right. It's a beautiful image, though. It's nice to see some live images tonight from different parts of the world. You know, so we've been, at times, it seems like everywhere in the world we went, we were clouded out. So this is great. And
that's how it's been for the last couple of weeks for me. And when I saw it was going to be clear for 2 days in a row, and last night it was clear, but it wasn't clear. So I'm just glad that I can show something, because I was getting a little backed up with no clear skies. So hopefully it clears out for everybody here soon. Hopefully all the fires get put out, burned out. Hopefully everyone does okay with it.
That's right. That's right. Yeah, I
hope for the best, you know.
Yeah. am still kind of watching the fires on Mount Wilson. I don't see the flames leaping up above the treetops anymore, but there is definitely a red glow still beyond the tree line. So that's, you know, it's something that's got a lot of people on pins and needles. But
hopefully they get some rain.
yeah, we need some rain. That's right. Astro Beard, thank you very much for showing this beautiful image of Mars. Maybe later you can show a processed image. So we'd like that on the.
See if the computer can hack that and everything else. We'll try. We'll give her a try.
Okay. All right.
Stop sharing now.
All right. Thanks. That's great. Okay. So we will go back to our grid view here, and we have not yet talked to spend any time with Ron Delvaux. Ron, you wanted to show what you got through your telescope and a couple of your reflectors.
Sure. Let me bring it up.
I love that saguaro cactus behind you. That's
yeah.
I am a fan of cactus. I love cactus.
Okay, let's see.
They require very little maintenance.
Very little. You don't do anything. Yeah.
Mhm.
Okay, let's see. What do I want to do here? I want to share the screen. Let's see if this comes up.
Okay. Oh, there it is.
Yep.
Oh, it's a nice view of Jupiter. Yes, it is.
Now, I'm using a program called EOS Movie Record. It's a Russian-made program. It makes the live view on a old camera like my 40D can be used, to take video.
Oh, wow.
I had a dirty lens on there, but
You can see the details of Jupiter popping in and out.
yeah. I don't usually take video with it this big, but
Mhm.
just for now. This camera is modded, so it's normally it shows it red or sometimes purple.
But I think we see the red spot off to the left there.
Yeah, I'm not sure if it's coming around or not. I keep it on tungsten. Anyway, so this program, if I just hit right here, it a bar comes up across the bottom and it shows that I'm recording. But I can't see it right now, I don't think. I usually do about 500 to 1,000 frames. Let's see. There's really no other function other than this 5X.
Sure.
You know, hear an airplane?
You hear it.
There's an airplane going over. All right, so enough of that. Let's see.
At LX200?
Sure.
Good. That's great.
I want to share, well, let's see. I was up 3 in the morning yesterday and took pictures of, are you looking at my,
We just see a yellow line running across the screen.
how about now?
Not yet.
All right, well, maybe I have to stop share and start it again.
Yeah, you have to pick the right window. Here we go.
Okay.
Delvaux Observatory.
Yeah. Here's my picture of Mars.
Wow.
Came out pretty nice.
Nice.
Yeah.
Very
You can
nice.
see, the cap is nice and clear.
Right.
All kinds of detail. Yeah.
So in Richard's view, we were seeing that
Yep.
flipped upside down or right side up. Look at that image. Beautiful.
Yeah.
Yeah. Isn't that so satisfying to see that? That's great.
Yeah, and I got the moon this morning before it went away. Now it's new moon, I guess.
Mm-hmm.
A lot of earthshine.
Beautiful.
And then some pictures of the moon. I do have a picture of, this is a video of all the smoke going by a couple days ago. This is my picture of, that's what's up. Oh, geez, I get the call. That's my picture of Andromeda Galaxy with a 200 millimeter lens, just very little processing, just threw it up. I'm not very good at processing. I only use Deep Sky Stacker and a few other things. Let's see, what else have I done? If you go back in time, I have some pictures I've taken of. Oh, here's Neowise. I might have shown that before. There's my two old
Oh yeah,
scopes.
yeah. Those
The
look.
first one here is it's University Optics. That they in Ann Arbor, Michigan. They made this scope. They usually make cell eyepieces that they make themselves, or they rebrand. I'm not sure exactly how they did it. And they used to sell mirrors and mirror cells, and but they never really made a scope. And so at one time they made this one scope. They made a couple others, but this one survived. I bought it from a guy in Michigan when I lived in Toledo, Ohio. The other scope is a Cave Astrola 8-inch f5. Both are f5s. The Astrola is f5.3, and yeah, they're great for visual observing, and I do a lot of it. I've done it for years.
Oh
And
yeah.
this is a Gulf green we got, and I put this was a Ramada. I put 4 sides on it, and I store my stuff in there when the weather's bad. But that's about it, guys. I have the scopes here. I don't know if you can see them. I have a big light. I don't know if you can.
Yeah. A little bit of glare, but we can definitely see.
Yeah.
Yeah.
The other one's back. I needed a light, so I just got one real quick.
Right. Yeah. Point the light the other way, and there we go. All right, we can see the scope now. Yep.
Yeah, there's the cave back there on the.
Yeah, an interesting story about Cave and Meade Instruments. There's a connection there. When Tom Cave decided to start to close down his business and retire, most of the engineers and manufacturing staff went to Meade Instruments during that.
Oh yeah.
Yeah. One of the optician guys went from Coulter Optical, that was up in Idlewild. And he eventually, that was Steve Murdoch. Eventually, Steve Murdoch went on, he quickly became vice president of optics. And then he went on to be, president of the company. And then he went on to be CEO of the company. So.
Neat. Both of those scopes I showed you were made in 1975. And
yeah.
The mirrors are still in great shape. They've never been redone or anything, and they're beautiful to look through. The drive on the Cave works still, and it has a declination drive motor. I didn't put it on, It came with it when I got it. The larger scope, the 10-inch. From guy in our club a whole lot of money, and
yeah,
my wife anyway, I've for my LX200 I traded 2 doesn't have a a wedge, so this one here I've taken a lot of everything that I can see.
Ron, we're having quite a bit of connection issues at this point. I'm not sure if it's, on my end or you.
If you see the
Yeah. Okay. Ron, we're going to jump over to
be mine because I'm about 50.
All right. Yeah, sorry, Ron, we're losing you. Okay, all right. So let's jump over to Jerry Hubble here. We lost Tyler. He had to head off to bed, but I did want to show what you got going on at the MSRO.
Yeah, we've been having a successful night here. I don't think. Can you see my screen?
Absolutely.
So I want to show just a quick webcam view of the observatory inside the observatory. Probably a lot of the viewers have seen this from previous episodes, but it'll come up here in a second. There it is. So these lights look much brighter than they actually are. You can see the night sky up through the slit here. It's very dark, but this camera is very sensitive. This is a ZWO camera that we're using, so it's highly sensitive camera. This is a 4-second exposure, so that's that. What I want to show is what we were doing earlier. We were doing M27, the Dumbbell Nebula, and this is a single frame from. We took 36 minutes of data, two minutes each frame, 18 frames, and this is a single frame from that run. You've got very tight stars. Our seeing was very good.
Yeah, it looks like salt speckled on top of the.
Yeah.
Very.
So this is the actual finished stack. It's 36 minutes. It's so you can see this is a full frame.
Mm-hmm.
It's 1.5. It's 1.4 by 0.9 degrees. So when you zoom up, you can see how nice it is. So our skies were very good.
Super.
We weren't impacted too much by the
dust,
yeah, and all that. Yeah.
Right.
Yeah. Right now, I wanted to show where we're at right now. We're just pointing. Tyler, before he left, we decided to point to this open cluster, TR37. Okay.
Mm-hmm.
And this is what it looks like. Really a very wide open. I think that's where we're at now. Maybe I moved the scope. I'm trying to think. Let's see. I'm going to position, see where the scope's actually pointed at. I think it's still there. Yeah, it's there. So this is an image, a 2-minute or 60-second image I just took with it. So This is a live image, and then just to give you an example of what we've been doing with these images, we've been doing plate solves, which I'm using Maxim DL to control the observatory.
Okay.
And we have Pinpoint, which is a Bob Denny program that's a plug-in to the Maxim DL. And so I'm going to process this, show you how quick it is. And there it is. And the measure, just to give you an example, this is an Explorer Scientific FPL 53-165 scope. It's got a native focal length of, I think it's 1151 millimeter. And I've got the 0.7 field flattener focal reducer on it, which yields a focal length of 850 millimeters, which I find is 1,000 millimeters. I always consider the sweet spot for imaging because of what the skies will give you in terms of, full width at half maximum. And, and you can see an example of that here. So once I did that, one of the things I demonstrated to Tyler was that you could, first of all, when you do that plate solve, you go to the FITS header file, which is a header of all the detailed information about the image, including the location and everything. But it calculates the pixel scale, or the full width at half maximum. And right now we're just a slightly undersampled. It's 2.05 pixels, which is very tight on the pixel scale. The other thing is that you can bring up the information window and go to astrometric, and I can actually zoom up a little bit. Let me get over here. And once you do the plate solve, you can click on a star and it'll give you the actual, it'll calculate the position and right ascension and declination down to down to 0.1 arc seconds, basically.
0.1.
0.1 arc seconds is the calculation.
Yeah.
It's the precision.
Oh, yeah.
So you can see this is the image star. This is the coordinates for the image star right here.
Right.
And this is the catalog information. So you can see in RA, our position measurement is 0.41 seconds, and it's 0.40. And declination is 0.1 arc seconds off. It's 29.00, 00.7, 29.00.8 is the actual catalog value. So you can see this is what we do when we measure asteroid positions.
Yeah.
That's how precise you can be with our images.
You know, Jerry, years ago I had to go repair a telescope for Meade Instruments. It was in Jordan. I think I've told you the story before, but the one of the professors of astronomy wanted the telescope to point like with arc seconds accuracy from one star that was in a double star set that was really only separated by 1 or 2 arc seconds. He wanted to go from this one to that one, okay, to know which one he was aiming at.
Yeah.
And I had to explain to this guy, that I don't think there's a telescope in the world that would point that accurately, just due to flexure and stuff like that, or the tube and mount bending and that kind of thing. Really took quite a bit of convincing. But had he had a program like this where he could do plate solving, okay, and certainly he wasn't doing that, it would have helped quite a bit. So,
well, you can see in this image of M27, you can see how precisely we could center the object.
Yeah. That's super. That's
within an arc minute, easily within a few half an arc minute probably.
Sure.
And it's a pleasure to work with a wide field. Now this is a pretty wide field, but we're critically sampling the sky, so we're not getting. If we even had a higher resolution camera, it wouldn't give us any more information at all.
I see.
We're squeezing all the information out of the sky that we can get with this camera. in this focal length in terms of the full width at half max. Now, if we were up on a mountain, we'd be grossly undersampled. But we're in a backyard.
Yeah.
So, you know, if you're doing deep sky with a 2,000 millimeter focal length scope, you're going to be really limiting your field of view that you should be able to take advantage of with a camera. So that's what we've been working on tonight, and the system's working great. That new focuser, I installed it a couple weeks ago. Actually, a few days ago, I installed a new filter wheel in a couple weeks ago and hadn't had a chance to try it out until just the night before last when the skies cleared up for us. So it's good to get the scope up and running and everything working.
Running. You guys were down for what, 3 or 4 days?
Oh, for three weeks probably.
3 weeks. Okay. Well, it's great to have it all.
We had the other station was down also because we had a computer failure.
Yeah.
We had to resolve, and then we had our LX200 mount failed on us, and it's down. So we don't have our 12-inch LX200 right now.
I might know a guy that can get you some electronics. So if that's what you guys need.
Oh, that would be nice.
Yeah. Yeah. There's still some of that out there. The guy would be Bill Vorse with Telescope Warehouse.
Oh,
yeah.
I don't recognize his name. We went to a guy that did a lot of work on the Meade electronics. What was his name? I can't remember now, but he does a lot, and he does upgrades now to the AutoStar system, which is expensive. We're a nonprofit organization and we take donations, but we actually kind of self-funding right now. We get some outside donations, but not a whole lot. And the observatory is the Mark Slade Remote Observatory. It's operated by the MSRO Science Incorporated, which is a nonprofit that we have.
Mm-hmm.
And we have people all over the world using the telescopes.
That's true. And they're seeing it all over the world right now, so it's awesome.
Mm-hmm.
Well, that's great. Thank you, Jerry. Thank you.
Yep, thanks.
All right. So let's go back to Caesar. Let's see what's happening out there. And no audio, Caesar. No audio. Yeah. Not sure what happened. Not yet.
This one?
Ah, that one. Yes.
I don't know why I have 3 options and change every time but change automatically, not me. Well, I don't know. Let me share the 2 things. The Jupiter now.
Okay.
Where I have just move these 2 videos. I'm preparing this for processing. I think that the last one maybe is the best, that have more possibilities to a good processing results.
Mm-hmm.
Because I had a local scene, maybe product of this here.
Ah, you do have Jupiter. I see it.
Yes. It's acceptable. I think that is acceptable.
It's great.
Yes, maybe I'll take some information of the structure in the wavelets, have some possibilities.
Sure.
Here you can see the one of the satellites, here another one. Well, and this was my hand, of course. Yeah.
Right.
yes, with a small telescope, you know that it's not easy. I'm really, I need to regret here. Here is another one that I like it. All are from tonight.
Mm-hmm.
This is very nice too.
Oh yeah. Absolutely.
Sometimes the
You
songs
stack.
have completely the characters of the color. I think that the great storm is here. The red, I don't remember in English. The Gran Tormenta Roja, the big but yes. Tomorrow, not today, not tonight. Tomorrow I'll process this.
Okay.
And that I'll share. Maybe we need to have something where we can share the image that we make in the third parties.
Well, we have something new, that which is the magazine that we're coming out with, and so do you know Marcelo Souza, Caesar?
I know Marcelo Souza from Brazil.
Right.
Oh yes.
Brazil is the senior editor now of Skies Up magazine, and this was a magazine that we used to publish. We're relaunching it, and so there is, if you go to the Facebook page for Skies Up magazine, you will see the. I'll lead you to it, and it would be a great place.
It's a great place to share. Not my image, because my image are more experiments to encourage the people.
Yeah.
To use the telescope in the city are not a high quality image. Only if you like to. I'm in the end of the last Friday, in the end of the Global Safari European edition.
Yeah.
I spent with you and Gary trying.
Yes, you are being blown away.
Yes, and Jerry too. That you are very kind with me, super me. Say okay, you can try. Was fun because after that we unconnected the edition, the Zoom. I say okay, it's running to be clear. Okay, I need to make this, and the image is it's incredible because the difference between each single picture and the final result was very interesting. And I don't use peaks in size because I say the more challenging was to say, okay, I use free software like I make all completely in Deep Sky Stacker. The image that yes, because the challenge was make with something with free software. It's inside is amazing, but in this type of image, maybe show to the people that it's possible to make something easy. I don't know if you like to share the compare with one single image. It's only 1 minute, if you like.
Yeah, please.
Okay. Let me go to the here. Well, as you can see, you, Gary, Jerry, each. This is the single image of single TFI or CR2 is the name of the raw image.
The raw image, okay.
Yeah. I don't know with which program. Okay.
Photoshop.
Yeah. Yes, because I remember that I had this the program that opened this automatically. Sorry, this it is a lot of time watching the Mermaid Girl that is completely outside of
Girl.
Okay.
Uh-huh.
Yeah. Okay.
Right.
Oh my God. Yeah. Okay.
There.
Well, this is the when it will open. This is the okay. A single shot was, of course, that was better that the first shots that we take together.
Sure.
Because we are all it's the same that I feel like we was around the telescope and suffering all together. This is the soul of the star party sometimes. Yes.
Right. That's right.
And I started to last. I don't have a great focus because as I talk with to Gary that they say and it's an all objective zoom from Canon and was very very difficult to me to make a great focus. But sometimes it's this program, Deep Sky Stacker, is very, very kind with the people and support any, but some type of mistakes in the picture are okay for the program. If you put these pictures in to stack in programs like PixInsight, the programs say no, come. Yes, return tomorrow with a picture, with a good.
Right.
Yes,
Right.
but this is for Deep Sky Stacker is nice. They say it's the program that this is why to talk with the people. The people want not us that we have a lot of years trying things in astronomy, but for the people, for the kids, especially or teenagers that come into to astronomy, show them type of tools very friendly, and it's very important. And all the time I'm finding free free software to these people to start. Say, for example, another one that I found is AutoStacker, but it's the AutoStacker for planets. But
okay,
well, I don't remember the name, but another one is very good and it's free for stack pictures. And well, I show you, of course, the final picture. Vamos a cancelar. Let's go to cancel. And what's a surprise for me, because I had no more than 18 minutes of information
So the group is now calling you 100-mile-per-hour Cesar. Because
sorry,
the group is now calling you 100 miles per hour Cesar because they think 100 miles per hour.
Oh my God.
Yes.
Well, this is the best option that I have. Sorry. Yeah.
Or Cesar.
Yeah.
Dusty wants to know, hey Scott, one way we could share pics from the star parties with everyone would be to set up a Discord server for the Twitch page too. We could. But where we're going to, where we'd like to share them, Dusty, is on the Skies Up magazine. And so let me give you a link that you can get to that magazine page.
Well, this is the This is the final result.
Oh yeah, check it out.
It's really.
47 to Ken. Is that the?
Sorry.
What is this object below and to the left of 47, where your mouse is running right there?
Yes, this is the Magellanic minor cloud. It's really difficult to see from the city. It's impossible to see, and in the picture, it's really was for me very surprising because you have here two NGC nebulas, and this is the whole entire cloud, and this is of course 47 Tucanae, the cloud that is that only we can see and few stars, but really, if we could make this in this city, that if I show you now, is that we can count no more than 10 stars.
Wow! Right.
And really it's impressive how with a small equipment and of course that the extras, yes, the mount work really properly, really, because you remember that we don't have a great focus, and I make only a 2 stars alignment and a roughly approximately polar alignment, because here in the south now I have a welding. I don't have any reference, no more than a compass and a latitude.
Yeah, and that's it. Wow.
Yes. The system work very good. The system when that computer, maybe Sherry can explain more about how work, but the relationship between the motors of declination and well, I don't remember now at this hour the name in English. Ascension recta is in Spain, in Spanish, and make this that we really we can get near to round stars. That work really properly. It's a really small amount.
Program does take into account misalignments and polar alignment, so it is driving both in declination and right ascension if you're off of polar alignment. So
right. So the mount model basically, it drives both motors, and it's in point mode. Is what it's doing. So it's continually pointing to the coordinates, the modeled coordinates for that object. So it 5 times a second it points to that object. So that's how it works.
Right.
Yeah. Was really proper. It's so helping to take this, because really I feel helped by the mount. This was real.
That's great.
A great job, really. I'm honest talking this.
Caesar, you did a great job. We are getting towards the end of our schedule here, but we're still going to have some time for going on further. But I do want to give Chuck the opportunity to ask the last door prize question for the night, and so he can get some rest. So, what time is it getting up?
I never get rest, Scott. I never get any.
Okay. Those executive officers at the Astronomical League never sleep. So
it's not that; it's all these all-nighters I've been spending at Patoka Lake.
Oh, that's true.
On top of the Zoom meetings. So
yeah.
Okay, we'll do the last question now.
Yep.
Let me share screen.
Okay. I appreciate your doing that, because we have a global audience, and sometimes people don't understand our American accents so well,
Yeah, hold on a minute. I gotta find this. All right.
Jeff says he just joined the Astronomical League today, so
fantastic.
Yeah.
All right, so we will go This is a slightly adjusted question since I accidentally displayed it earlier. I adjusted this question. This is the third one. Who first proposed the method used by Jérôme Lalande to determine the distance to the sun in 1769?
This is an interesting question.
Okay, now it was Lalande who determined the distance in 1769, but someone earlier proposed it first, and I'm looking for that name.
Okay.
Okay.
Very interesting. Very interesting. Okay. Who first proposed the method used by Jérôme Lalande to determine the distance to the sun in 1769?
Yeah, there's a dangling modifier there. The 1769 is not when the proposal was made.
Oh, okay.
It was made far earlier.
Far earlier. Way before 1769. Yep. That's right. That's right, Jeff. Questions do get tougher as we go along here. And we have Chuck Allen posing the questions. So, you didn't think he was going to make it easy, did you? So there you go.
Well, they complained about my questions being hard.
I know.
Okay.
That's awesome. Chuck, thank you so much. Thank
you, Scott, for the invitation
tonight and mentioning the National Young Astronomers Award. I know that you were the person that launched that. When I first met you, I met you with Bob Gent, and you guys gave me the history of the National Young Astronomers Award. But it's just one of the many awards that the Astronomical League does, and to recognize special individuals and people for all their achievements. And you guys have been doing this for a very long time, so that's great. That's great. You're changing people's lives.
Thank you again. So are you.
Thank you. All right, Chuck. Well, take care, and we will go back to the rest of our astronomers here that are remaining. The Astro Vikings of the of the Global Star Party, because they're still here, and I think Gary Palmer is at the top of the pack here. So, Gary, you got anything to add before we call it a night?
No, I think it's been a really good night again, Scott. Very interesting people on tonight.
Yes. So
it's now just coming up to 6:30 a.m. So I'm about to finish up and get a few hours sleep before we start solar imaging probably this afternoon.
Oh my goodness. Okay. We have some good rest, Gary, and we'll see you. Our next Global Star Party, so you guys know, is next Tuesday. So that is going to be the 22nd, and then we will have a Friday European edition of the Global Star Party, which will be the 25th. So we'll put out announcements for that as soon as possible, and that should be a lot of fun. So we'll try.
Next one's number 10. Number 10.
Yeah, it's going to be cool. How about you, Richard? Do you have more to share with us before we go?
I do.
Okay. I'm going to give you the spotlight.
Again?
Yep.
That is not the process image. 1 second here. Let's see.
I love your radio announcer's voice, Richard. You've got.
It's partially the microphone, I guess.
Is it? Yeah. It's not all the microphone.
No. I've been talking on the radio for a while.
Long time. Yeah, that's cool.
This is what we ended up getting with a real quick edit. And we did manage to pull out a couple things that might be artifacts, but there's a couple things that look kind of vaguely round down in that area. It's a little darker, and I don't know if one of those craters might be real or not, but
You want to share your screen, Richard? We just see your
Screen
camera.
It is late.
Excellent.
Ah.
Oh, look at that.
Cool.
Nice.
yeah, I just let it stack up and threw the first thing that I got into Pix Insight.
Taken tonight, right?
I'm sorry?
This is from tonight.
Yeah, it was from like an hour ago.
Oh wow!
I just took the first stack that I got. I guess it was 1,000 images and a video, 8-bit, AVI file. Threw it into AutoStacker and let it do its thing. And it said that the quality was about that good, which isn't very good, but whatever.
Excellent.
That's good.
And we'll take it. And I'm happy because honestly, other than taking a picture of Mars next to the moon, this is really my first half decent image on Mars.
Yeah, I love it. It's great, man.
Thank you.
It's great.
Appreciate it. And yeah, it's been a good time. It's always a good party. And to everybody out there watching, follow, like, subscribe, all the people who
that's right.
Participate.
Subscribe, ring the bell,
click the heart.
Share with your friends. Yep. Like us, share us. Thank you. That's awesome. Thanks, Richard.
No problem.
That's awesome. Okay, and let's see.
You're the last.
Yeah. So how about you? How about you, Caesar?
Yes, it's the same in the.
Okay.
With the guy that we are the last that.
Yeah, you guys are always the last ones.
Yes, yes. Normally, when I say if you go to the star party, say it's Caesar with 3 or 4 guys more. Yeah.
That's right. Yeah. I except I don't have my hot cocoa with the marshmallows in it. So,
Yes, something like this. Yeah.
How about you, Jerry? Is there anything else?
Yeah, I moved over. I went ahead and moved to M31 Andromeda Galaxy.
All right.
Do a few images. These are the raw images. So let me share my screen.
All right.
All right. You can see that.
Wow.
These are coming in pretty good. So if you look.
Oh yeah, you can see the dust.
You can see, this is a 2-minute image. So once I stack these and get the stretching correctly and the processing right so that's not blown out, you'll be able to see quite a bit, I think, in here.
Oh yeah.
But again, our seeing, I haven't had to touch the focus tonight really at all. It's pretty amazing how the seeing has been really stable.
Mm-hmm.
And the temperature has been fairly stable, so I just let it rip.
Sure.
And I don't know that I've ever really imaged in M31 before a whole lot, to tell you the truth.
Really? Why not?
Yeah, I don't know. I'm not a deep sky guy, so.
I'm not a deep sky guy.
So if I'm just goofing off, this is what I do when I'm goofing off. It's like.
Well,
I'm real serious about what I'm imaging. I'm just
good.
Going around the star chart looking for stuff.
Yeah.
So this is what it looks like in Chart to Seal.
Hey, there's a question before I forget it here. Jeff Weiss wanted to know what kind of camera you're using to image tonight.
So I'm using the QHY 163 color camera that we have a filter wheel on. So when we do science imaging with that color camera,
yeah,
we have an open position so we can do color, one-shot color, but we bend it by 2 to do science imaging along with the filters that we use. We also have a spectral grading that we do spectra with also on the filter wheel. So we can do all kinds of work with this system the way we've got it set up. And I've validated that you can bend the color pixels into one monochrome pixel, and it's very linear. It's so I basically took some test images of M67,
yeah,
and did a measurement across that frame with the photometry. Astrometrica does a great job of creating an image catalog of the star positions and the measured brightness. And so I bounced that against so you compare the image brightness against the catalog brightness, and you fit the line to that, and it's very linear. So I validated that I could do V-band imaging with the one-shot color camera.
Oh, that's cool.
So that works. Although it's not as, with the Bayer filter array on there, you don't get quite the transmission that you do with a monochrome camera, but it does pretty well.
So it's almost like you got two cameras in one, a monochrome and a color camera.
Right. Exactly.
Do you think most of the color cameras out there could do this pretty well, or
I imagine so.
special?
We set the gain and the offset. The gain is set to the highest dynamic range for the camera. It's a pretty low gain value, but it gives us the most dynamic range, and it's the cleanest image that we can get also. And this is an uncalibrated. That one I showed earlier. Let me show you the dumbbell.
Okay.
This is uncalibrated. There's no flats applied. There's no bias or darks.
It's a single shot.
It's very nice.
And there's no, you can see there's no gradient. There's no, I think there's one donut that's on, it's not a donut, it's actually a circle because it's a refractor. But there's only one spot that's got dust. There's only one dust spot on this since I cleaned it at last week or week before last when I had it all apart.
Mm-hmm.
So these CMOS cameras are amazing.
Yeah, that's true.
They're very clean.
Yeah, but better than they used to be. That's for sure.
Yeah.
I think they really compete very nicely to science CCD cameras, the past.
Yeah. Well, they're getting there. Still there?
Yep. Still.
Okay. It got quiet.
No, I'm reading the chats.
You weren't moving around. I thought maybe my
minus 20.
In the chats. So, anyways, Brett Blake says color cameras can't figure out what RGGB pixel they're dealing with when binning.
So it doesn't matter. All you care about is the total number of photons on each of those four those 4 pixels. You just sum the pixels. You don't care what color they are.
Yeah.
You just bring them in, and the filter takes care of filtering the colors.
Celtic Raven wants to know what's your virtual background. That's not a virtual background. He's actually back in 1969 at the Apollo Mission Control. So
That's
he's
right. So don't you know I'm in black and white? This is an old-fashioned black and white camera that I'm using here.
Is it really?
No.
Yeah, no, it looks pretty authentic. I love it. You just need more static and stuff, so yeah.
Right.
Where it kind of goes in and out every once in a while as I adjust the rabbit ears, so. And for all you guys that were born not too long ago, you won't know what rabbit ears are, but you know what they are, so.
You type in rabbit ears and TV on the Google and you'll find out.
That's right. Very funny. I'm going to share my screen here because I want to show what's going on at Mount Wilson right now. So let's. This is the HP Ren camera at Mount Wilson. This is a pretty fresh view. You can see there's some lights turned on at the 100-inch dome just outside, and looks like the flames have hopefully died down a bit down below the mountain. So, I don't know if these guys are out of the weeds yet, but so far they're dodging the bullet. So let's keep our fingers crossed for Mount Wilson Observatory. And I think
Zoom just gave me the function to cancel the spotlight off of me. It came up with a little button over top of my image. That was pretty cool.
Did it? Well, that's nice. So, well, gentlemen, I think that we're wrapped up here. Caesar, did you make any more pizzas?
Oh, last Friday was amazing. Delivery, no, not delivery. Was yes, but tonight not. No, tonight was.
All right. So anyone wants to order a pizza from the real Caesar Pizzas, okay? You will.
Yeah,
I will send you.
I love it to make Italian pasta or pizzas. It's real.
For only $500, he will produce a pizza for you and have it shipped anywhere overnight.
Yeah.
He said it wasn't delivery.
That's,
He said it
that's
wasn't
right.
delivery. It's DiGiorno, maybe. I don't know. He doesn't know that commercial.
And when COVID is over, for only $5,000, he'll deliver to you in person. Okay, he'll come to your house and make a pizza for you.
No, it's most easy. It's most easy that one time in the future we can enjoy together something like this. Yeah.
I'm sure. We're going to have
Argentina and Chile and or in United
pizza machines
so.
in the future. So, yeah, that's right. Every household will have one. Well, it was great, gentlemen. I really thank you for being with me tonight, being with us.
Thank you.
And let's see if we have any more questions from the group here. Celtic Raven says, Caesar, I'll take the cook-off challenge when I get down there one day. That's right. That's right. And Kelly Latourneau says, true heroes working on those fires. That's true. It is, it's dangerous work. Unfortunately, some of these guys lose their lives fighting fires like that. And it's pretty crazy. So, I've got family in California, and of course, they're all safe, but, none of them have seen smoke and fires like this in their lives down there. So it's some of the worst fires in recent history. So, for sure. Well, you guys have a good night. Thank you very much. I'm going to put the spotlight on me, and we are going to close out. We'll be back tomorrow at 4 o'clock for the OpenGo2 Community Live with Explore Alliance. And we'll be talking more about Skies Up Magazine and how you can participate in that. And we hope you do if you're a writer or an astrophotographer or someone that makes visualizations, science visualizations for astronomy or cosmology. We are very interested right now. We have a quick timeline on this next issue, which is the deadline is September 30th, so it's coming up really quick, and we hope to get some submissions from you out there in the public. Until then, as Jack Horkheimer always said, keep looking up, and we will see you soon.